Hello. Hello, is sound working? Can anyone hear me?
I can hear you. I'm Warren.
Hi, Warren. Hello.
Hello.
Hello, the room. Can anyone hear us?
Yes, I can hear.
Hi, Warren. Sorry, I'm trying to see if anyone in the actual meeting room can hear us. I think they might be muted there.
Yeah.
Hi, testing.
Hi, Connie.
You want to try it?
Can hear you? Can you hear us, Connie?
Yes, I can hear.
Hello. Hi, Connie. Can you hear us, Connie?
Michael, I hear your
Yeah, there must be a delay.
like 10, 15 seconds later. It was
Good
there was
morning. Can I just ask the people who are online if they can hear me?
Yes, we can, Connie.
Okay. And can you see the screen?
A slide center for protection of dogs. Yeah, like 10, 15 seconds later. Yes, we can.
Good morning. Can I just ask the people who are online if they can hear me?
There's something which is lagging.
Okay. And can you see the screen?
Slides and.
Okay. Thank you very much. All right. All right. I want to say hello to everybody. And the room is filling up. It's wonderful to see. My name is Connie Walker, and I am a scientist at NOIR Lab, NSF NOIR Lab in Tucson, Arizona. And that's the National Optical Astronomy Lab for the United States. I'm also a co-director of the wonderful center you're going to hear all about today, the Center for the Protection of the Dark and Quiet Sky from Satellite Constellation Interference, and we shorten that to CPS, and you'll hear that phrase heard a lot today. Okay. I guess for some, yeah, okay. So what I want to do first, if you don't mind, is I want to acknowledge the people that are involved in CPS. And I want to have Federico and Richard stand, please, for a second. And Richard, you'll hear about in a moment. He's our interim director. And Federico here is one of our co-directors, along with myself. And then we have Siegfried in the audience here, who is one of our co-leads for the hub called Sat Hub. And John and Jessica, I know people online can't see this, but John and Jessica are the co-leads for the Community Engagement Hub. So you're going to meet a lot of people, and the rest I think are pretty much online, but they are incredible. We could not do this without everybody's help. So what I'm doing today is basically an invitation for everybody, as much as you can or as little as you want to, get involved with this particular project, and we're going to tell you all about it in the hour and a half that ensues and the rest of the day as well. So what I want to say first is a welcome, and to give a point here about respecting the code of conduct. We always put this at the beginning of our meetings because some of these topics can be a little heavy to talk about sometimes. So please remember that the IAU does have a code of conduct, and it's on their web pages. We also want to say that the lightning talks that happen today, right after Richard speaks and gives the invited talk, are going to be about 2 minutes. So speakers, please be apprised of that, 2 minutes, and the session chairs will be doing a very strict timing. Presenters, please be pretty close to the mic, not too close, but as close as you can at home and at work and here. And please, if you have more than one slide, say next slide so that the technicians can know if you're not advancing it yourself. And then to ask questions, we have on Zoom, we have a chat tool, and you can also raise your hand. So please, we're going to be aware of that. We have a moderator that's in charge of the question and answers that's from our group. And so we'll be apprised of that. And then the chair, whoever's the chair, will be apprised of taking the questions in the room. So people in the room, please feel free to raise your hand. And then everybody, if you want to, please stay in touch with us, especially during this General Assembly and afterwards. But during the General Assembly, we have our Slack channels shown here. And without further ado, I want to introduce our invited speaker. Oh, actually, darn, I forgot. Okay, we have many events happening. Not only this one today for the whole day until 5 p.m., but we have a wrap-up session that focuses on the priorities and pathways forward, and we'd like to have you join us tomorrow. It is at 8 o'clock in the morning, but it's going to be a great session, and it'll wrap up everything from today and look forward and ask how you might want to be involved if you do. And then on the 12th, we have a business meeting, and this is for Dark and Quiet Skies Protection. It's actually a site protection group, Commission B7, for existing and potential observatory sites. And we have a meeting, and where's James? Is James here? So James is our next president of the commission. I am the former one, but he's the next president. So if you have any complaints, talk to him. No. And he's going to be, with a little bit from me, leading that meeting, and that'll be a very good, productive meeting, I think. And then the 15th, we have another session primarily on ground-based light pollution and radio interference, and that's going to be all day on the 15th. And we have the rooms listed there for your convenience. Okay, so now we have a introduction to, I think, one of the most incredible people on earth, because he very, very gracefully and very effectively is a leader and has led us in the last 10 months to direct the center, the CPS, and you can see the litany of various accomplishments that he has had over the past couple decades, I think, and he has been incredible as directors of major facilities. And I really want to thank him. We all from CPS want to thank him for stepping in, because Piero Benvenuti, who is here in the audience, you want to say hello, Piero, for a second? He has been our director for the CPS before that, for a couple of years before that, and he's going to again assume that role when he actually steps down as the General Secretariat of the IAU, which he's done an excellent job in the past 10 months. So without further ado, if you don't mind, I'm going to have Richard come to the podium and give his invited talk. It's pretty self-explanatory.
Cool. Thank you, Connie, for such a generous introduction. And I have to ask you guys to advance the slides, or can I do it? I can do it, great. Okay, so as we all here know, there has been a sea change in the use of near-Earth space, in that it is now dominated by commercial use rather than scientific and a little bit of military use. And that's going to change our view and ability to view the night sky essentially forever. So, as you know, we're facing an exponential increase in space activity. Jonathan McDowell, who serves as an active member of our groups, tracks and catalogs the publicly available information, and just know that we're on the way to 10,000 satellites already, and the ambition is limitless in that not everything that gets registered gets done, but there are now approximately 1 million satellites in the registry of ambitions for the future. So how does that affect the night sky? Well, we're here because it affects professional astronomy. It has impacts on the natural world. There are stunning experiments of nighttime bird navigation that depend on stars and get confused when stars move. The night sky, for example, in the US National Park System is considered an integral part of the natural world. It is being transformed. Astrophotographers face a plethora of new non-natural phenomena, and amateur astronomers, and for cultural heritage, its use of the sky by certain parts of the population without the discussion of native practitioners. So, to state the obvious, how does it interfere? They reflect sunlight. They reflect sunlight onto the night side of the Earth, and as they pass quite rapidly through a field of view, they reflect sunlight and make streaks. And they emit radio radiation in bands that are indeed theirs to use, but were before protected, at least from the ground, by radio quiet zones. Now they're not. And unshielded electronics emit low-frequency radiation that interferes with early universe and planetary studies. So on a narrow field, the anticipation is that about 10% of images are going to be affected, but current wide-field telescopes, maybe 50% of the frames, particularly in twilight, and that's an interesting time to look for near-Earth objects. And for the very wide field of Rubin Observatory, it's very likely that all frames in twilight will have a streak or more, and many frames during the whole night. So, in fact, the brightness limits that were set had to do with the combination of saving area in Rubin images on what's calibratable alongside the streaks from the CCD crosstalk, and from making them in orbital operations not visible to the naked eye, so minimizing the impact on the creatures who are used to light limits. And that being said, that's for operational orbit. And if there are, SpaceX last year achieved about a launch every other week. And so satellites will always be in transition going up to station and coming down, and they are brighter because they're closer. Radio frequency interference, likewise, there needs to be a direct negotiation to make sure that full power downlinks don't happen straight on to the sensitive radio instruments. Our jargon is UEMR for the low frequency noise that comes out of unshielded electronics. That's unintended electromagnetic radiation. And without regulation of that, Federico already measured in LOFAR and in other low frequency arrays that you see these satellites if no provision is made. But more to the point, they are licensed communications bands that they are allowed to use, and it fills the sky with much stronger radio noise that formerly radio telescopes could observe. So the range of frequencies that's getting impacted by, quote, legal noise is increasing all the time now. And you could say, okay, just send everything in space, but just know that low Earth orbit is the same height as these satellites, and they reflect sunlight right into Hubble. So, you know, it's an impact for everything we do. So, IAU recognized this problem with the launch of the first tranche of satellites, and recognized that this is an international problem. No one country's fixing things. They orbit the entire Earth. They affect everybody's telescopes. And it's an international problem. So Piero and our colleagues went to the UN and have been working with them and created this center, the CPS. And so the job of the CPS is to organize the energy of volunteers to promote mitigations and to promote policies and regulations that actually can make some impact to lessen the strong and growing effects on our field. So here's a quick view of the organization. What I care about on this is that there are 4 main activities into which people devote their volunteer time. And they'll talk a little bit about each one before we get into detail at the session this morning. So there is the SAT hub, the satellite hub for astronomy side mitigations. There's a policy hub that has done deep international law and national policy analysis so that we can go in an informed way and influence policymakers. There's an industry and technology hub, which now has 15 satellite constellation and operators and new space companies that are sitting down with astronomers and saying, yeah, we care about this and we want to do voluntary cooperation. Let's share technologies to see how we can mitigate things. And the Community Engagement Hub, which you will hear more from, but we need growing awareness of this problem in order to have the bottom-up pressure to actually get some action and mitigations. So one by one, the hubs quickly. The policy hub wants to raise awareness among policymaking circles, and they've done that. They've gotten statements from the G7 and the ESO Zero Debris Charter, just for example. We aspire to have a common policy so that when national astronomical societies go out and try to influence national policy, we're having the same goal, even though the path to get there might be different. We want a regulatory environment that industry won't torpedo and will actually be effective. And spectrum management has these real issues because the radio regulation apparatus through the UN is very mature, but they still haven't embraced the notion that they need to regulate electronic noise. They said, well, that's not radio broadcast. So we have a ways to go. SatHub is doing amazing things, so they have, and they'll tell you about it, but they have repositories of data. They coordinate the observations of satellites in new forms and look for the effectiveness of how they're trying to dim their appearance. There's great news in that they've just gotten a big grant from the U.S. National Science Foundation to tap into the publicly accessible position database so that ultimately astronomers can say, I'm pointing at this altitude and azimuth at this time for this many minutes, what's going through my field and how bright will it be? So you can actually, for those telescopes that have options, can plan their observations. And then it really is a forum for collaborating on all this information, and you'll hear a lot more about it. Community Engagement Hub has, and they will tell you about it, but it's a combination of providing good informational material at public level and engaging communities whose voices might otherwise not be heard in how we formulate the debate on dealing with this problem. Industry and Technology Hub they also call it a safe space where their corporate members can sit down, try to understand the problems we are having, and share technological solutions. And so, for example, SpaceX reverse engineered a coating, which is basically a Bragg mirror that sends the reflected sunlight off in a different direction rather than to the ground, and they sell that to other companies at cost, so that they're devising solutions and sharing. An international solution requires international influence. So thanks to my predecessors, Piero and Federico and Connie, within the UN commission that oversees the Outer Space Treaty, there's a group of now 17 countries that have agreed that this is an issue that they should unite on and promote international regulatory approach. They call themselves the Group of Friends, and they, after a real struggle, achieved the discussion of a 5-year agenda item on what the implications of satellite constellations are and how they might be mitigated. And so that will start in next February's session, and the IAU is the secretariat. We provide most of the technical input to the group for their discussion, and we are helping them formulate their positions. So we'll continue to play a key role with that group. And that's what that says. So what should you take home from this? That we think that mitigating the brightness and the radio loudness of this new generation of many thousands of satellites is a key part of sustainable use of space. So it goes along, I mean, that's a buzzword where industry thinks that means exponentially increasing forever. So everybody has their own definition of sustainable use, but honestly, for this, where it's long-term and it minimizes impacts, we think that our concerns are an integral part of that. And for astronomy, for space science, for cultural heritage, and for the space environment, this is a problem that must be dealt with. Careful control of radio frequencies is a similarly integral part, and that is an even more uphill struggle because of strong commercial and profit-oriented interests that are going to resist paying attention to this problem. And regulation, as you learn if you've ever gone to your government, or particularly the UN, is not a fast process. And so the fastest way for us to get started is to be sitting down with industry and seeing how far they will go in understanding and addressing the problem. And so that's a fundamental approach of what we're doing. So we would love to have as many people as possible participating in this effort. And so part of the reason we're here is to talk to you and understand how you could help and how we could engage you. So, thanks. I haven't watched the timer at all. Okay, so does anybody have questions? It was, yes.
Good.
Hi, sorry. So my question is mainly on what's the impact of these mitigation steps on space situational awareness as we reduce the reflected sunlight?
That's a great question, because we would argue that, the greater the contamination from commercial satellites, the harder it is to track the fainter space debris, much less potentially hazardous asteroids. So we would argue that SSA is helped by doing these mitigations. Ruskin. They want to hear you. Yeah, they want to hear you online.
Hi, Richard. Ruskin Hartley with Dark Sky. It's great to see how far this has come over the last 5 years, so congratulations. How do we deal with the challenge that, from the sense of the public perception, astronomy has solved this problem by putting a very expensive telescope at Lagrange point, and we're talking about astronomy on the moon, so even some of the operators are now talking about, oh, we'll just go to Mars. So like, we've solved this problem, there's not an issue here, move on. How do we respond to that as a community?
So that's an excellent question. And if you ask NASA astrophysics, they will tell you all their future missions are intended to get beyond LEO, to a Lagrange point. So I am open to your suggestions for how we make the point that there are a dozen large aperture telescopes representing the huge capital investment in ground-based astronomy, that you can't launch radio telescopes into space typically, that there are hundreds, if not thousands, of useful sort of 1 meter class telescopes with wide field for instruction and for monitoring, and that are doing both forefront science and bringing in the next generation of the field. So it's like saying, if there's 2 giant electron microscopes, you don't need little labs anymore. It's a pyramidal infrastructure. But that's a pretty subtle point. And so how we convince the public of that, I think we all need to think about together. Okay, so now I want to introduce Siegfried Egel from the University of Illinois. He is one of the co-leads of the SAT Hub, and he's going to be leading this lightning round for all the contributions of people who are working on measurement and prediction.
Thank you very, very much, Richard, for the excellent talk. If you have more questions, this is not the end of it. After the lightning talks, there's going to be a question and answer and discussion session where you can ask questions to your heart's content. So just be aware of that, please. The next session will be a lightning talk session. And before I start that, just let me say that I am here in my capacity as the co-lead of the IAU CPS setup. And it is my great pleasure to also introduce the other 2 co-leads, Mike Peel, who is monitoring for questions online, and Meredith Rawls, who can't be with us today, unfortunately. But I think together we are a really great team. And if you have any questions regarding any technical aspects of satellite mitigation, please feel free to reach out not only to the management team, who do an excellent job of doing this, but also to each of us individually. So now a lot of you are going to have presentations now in this lightning talk, and I apologize in advance that they're only going to be 2 minutes, but as you will be seeing, we've been heavily oversubscribed. And so this is really just to come to the main point that you want to make. Please, when you see your slide pop up, get up, make your way to the podium. We have that kind of time. But then please really get to the point very quickly. I have to be strict, and if you go beyond 2 minutes, I have to kindly escort you off the stage. I put on weight specifically for this purpose, so I think it will be a challenge to resist me in that sense. So I will be keeping time, and so please just make your point and then move on to give the next speaker ample time to discuss their points. If the audience has questions, I would kindly ask you to hold off until the question and answer session and discussion session afterwards. Otherwise, it'll be very difficult to keep that kind of pace going. If you are afraid that you forget whatever you wanted to ask, please post them on the Slack channel. There is a dedicated Slack channel. It's called, I think, hashtag CPS SetCons in the IAU Slack, or post them on the Zoom link for folks online. Mike will monitor this, and it'll come back. We won't forget about it, I promise. Please do not think that the 2 minutes that you have here are all that people are going to get from your excellent science that you are doing. There are posters that are online for at least like today and in the next coming days. Please do have a look at the posters. They're really excellent, and people have put a lot of effort into making those available to you. So the 2-minute talk is not all you get. Please do take the time to watch the posters if you feel that this is interesting to you. And last but not least, I think the amount of people that I see here is an indication that this is a real concern for astronomy. And the fact that that you show interest and that you are contributing here is really what it takes, to stand against this real concern that we all share. And without further ado, I would like to call up our first speaker for the session, that is Priya. Please make your way to the podium. And just for folks to prepare, the next speaker will be Connie, and then after that will be Joko. Thank you so much. And I will be advancing the slide if you don't mind.
Thank you. So hello everyone, I'm Priya, and I'm essentially an observational astronomer, and that's how I got very attracted by the CPS. Did the poster show up? Will the poster show up? Oh yeah, great, yeah. So the problem is obviously during observations, the biggest problem is if you have satellite invention. The picture was already showed by Richard, which is on the left. Nobody wants an image like that with all those satellite trails. And therefore, there are various things being done about it. And I am basically more interested in the educational aspect about it, of how could we actually make astronomers aware about this and what are the things they can do. What you see in the images are, what you see right down there is that basically satellites are reflecting the light from the sun. So the problem is going to be in dusk and twilight. But if you are observing on winter night, which is short, a good chunk of your night will go off because of the trails. And the problem is also that if your satellites are low Earth orbit, they will cross faster, but they'll be brighter. If you have them higher, they will be fainter, but they'll stay on the sky for a longer time. So then there were two proposed solutions. One was the dark sat and the visor sat, which would hopefully reduce the reflection. And then there's the other aspect about getting astronomers aware in the sense, I have not put that in the poster, but for example, the past predict software, which can actually, if satellite industry people give us all the information about their satellites, then one can actually predict the passage of the satellite. So hopefully you can plan your observations depending upon that. And then the other thing is, worst comes to us, if you do have these objects, then how do you mask your images? Masking is not a good solution because you're just blocking out data, but that's the only thing one can do if you want to then handle data which has that. So it's a problem. Obviously, the problem is that on the other side, you have money. These are money-making machines, the industry. They're not going to listen to your beautiful things about science and research, and therefore getting a common agreement between both parties is obviously difficult. So yeah, let's hope we find a solution to this problem. Thanks.
Okay, next slide, please. Hey, everybody, it's me again. I'm I have a very great setup from Priya, so all I'm going to say is the highlights of this poster so that you yourself can go down and select it and take a peek at it. But what I've done actually here is I've set up to 3 sections. One is the challenges, one is then a set of solutions, and then how you can possibly get an opportunity to get involved. And so I go into the increase in the number of satellites as part of the challenge and the visibility of the satellites and their brightnesses. And then I go into the impact on optical astronomy. And then someone else, Federico, is going to go into radio astronomy in another poster. So, and then I go into the mitigations by the astronomy community, and then the mitigations by the satellite operators. And then I will touch on the center and how you might want to get involved in helping to mitigate the situation in various ways. And that's shown in the bottom left, the various ways that we have already accomplished things and the various hubs that you can get involved in if you're interested. And then more information. In the past, we had a wonderful conference last October with not only work from CPS, but from the greater community, and lots of information there if you want to get any background information. And then, of course, this session here is the poster on the right of the bottom middle panel. And then at the bottom right, we just tell you the ways you might possibly want to get involved. But there's other ways, too, I'm sure that you yourself can think of. And that's the summary of my poster. Thank you.
Good morning, everyone. I'm just a messenger. Meredith Rawls made this poster. And of course, we had relentless Tony Tyson pushing us from behind. So there is one simple message I want to convey, and that is the answer to the question, how bad will this be for Rubin? Rubin is the most sensitive facility to these effects. So the answer is, based on what we know now, it's a nuisance rather than catastrophe for Rubin. In other words, we are going to lose about 1%, up to 1% of all pixels by masking these trails. And translated to money, it's about $15 million, 1% of the cost of Rubin Observatory. Now, if there will be million satellites, as Richard showed, could be, then it's much worse. Then we could lose 10% or maybe even more if these satellites are much brighter than they are today. So that's the message. It's nuisance right now, it's not catastrophe, but it is plausible that if those plans materialize for the satellite constellations, that it could be catastrophe. Thank you.
I hope everyone can see me okay.
Us online. If you are, just please unmute and you can go.
Yep, can you hear me okay? Siegfried?
Yes, Jeremy, we can hear you.
Oh,
There's still a bit
brilliant.
of an echo, so you go ahead.
Okay, brilliant. Okay, so thank you for giving this brief talk. Basically, I'm going to be discussing about using machine learning to hunt for satellite trails in astronomical images. Basically, with the CLEOSat group, or the Chilean Low Earth Orbit Satellite Group here in Chile, which is also a member of the CPS. Basically, we've been sending out telescope proposals to get dedicated time on telescopes to observe satellites. The issue is that's taking time away from actual
Jeremy,
astronomy.
I'm very sorry. We have a bit of an issue here with the audio. I may have to ask you to come again in a minute or so when we hopefully have fixed that on our end.
Okay. So, yeah, do you want me to stop for now then?
I think so, yeah. Thanks, Jeremy.
Okay.
Can we try again, please? Jeremy, would you mind trying again, please?
Okay, can you hear me okay now? Is the audio better?
Yes, we can hear you now. Thank you.
Okay,
Just
brilliant. Okay.
start.
I'll start again. Okay, thank you. Okay, so basically, what we've been doing here with the Chilean Low Earth Orbit Satellite Group, which is a member of the CPS, is we've been taking observations of Starlink satellites, so OneWeb and Blue Walker.
I'm afraid we still have that issue.
Okay.
Jeremy, would you mind hanging on for a second until
Okay.
set checker is already online. So if you go and join the CPS, we'll have you get a glimpse, but eventually all those services are going to be publicly available. There's also an open satellite brightness measurement database that's called Satellite Constellation Repository, or SCORE, that is also currently being tested. This is basically where you can put all your brightness measurement data, and that is hopefully something that's really useful to everybody. All right, I think that's my 2 minutes. Thank you so much. Shall we move on to the next person?
Morning, everybody. Please, on the side, please. So, how many radio astronomers do we have in the room by a show of hands? Okay, what do you do with your RFI data? You throw them away. You don't care about them. And I love those junk. There are lots of claims that we scientists will make, but remember that claims are an anecdote, are not data. There are claims that the RFI is changing, is evolving. We want nighttime observation or daytime observation. So my project is basically how can we quantify the amount of RFI, the probability of picking up RFI from your instrument. We also have a small transient array radio telescope, which is a TART. We have one setup downstairs, which allows you to detect and make images of satellite at your location. So I use the Meerkat data. Can we go to the next slide, please? Yeah, so that's images that you can make from the TART, which is downstairs. And the next one, please. So I use the Meerkat data to calculate a probabilistic model of picking up RFI as a function of time, frequency, baseline, azimuth, elevation, and the date of observation. So I've analyzed over 1 petabytes of data. So the probability, if you want a good sample, that's the best sample you can have. It gives you the probability that you can slice. And now, if you come and tell me that, oh, I want nighttime observation for my science, there's only 3 or 4% difference between nighttime and daytime. So it's not justifiable. So it's an easy algorithm that you can run at any observatory, and any observation that's coming through your telescope, you get your probability of RFI. I have a poster also, number 76. Thank you.
Thank you so much. I think we're going to try Jeremy again. Jeremy, if you can hear me, we're going.
Yep. I can hear you, Siegfried.
Thanks, Sir Jeremy. Just one more second. If anybody is online, please kindly mute yourselves, because I think we get the feedback through the YouTube channel that somebody is watching too. So please make sure everybody online mute yourselves. I'll give you a second to do that. And then Jeremy, please do unmute. And then. Okay. I think, Jeremy, you can go now.
Okay. So I'm just trying to work out if my slides are. Ooh, I can't see. Okay, doesn't matter. I can't see my slide. But basically, here what we've been doing here in Chile is
Could
basically.
we please get the slides back up? Yes.
Okay, so basically what we've been doing here in Chile is doing coordinated observations of Starlink satellites, OneWeb, Blue Walker, to measure their effective brightness and measure accuracy of the TLE. However, what we'll be doing there is taking dedicated time away from telescopes to actually away from science. So one thing that we're now looking into is basically developing machine learning to actually detect these trails in astronomical survey data. So that's basically NGTS, WASP.
Jeremy?
Yep.
Jeremy, I am extremely sorry, but this still doesn't work.
Right.
We still hear multiple echoes in this. We will have to find another way to do this.
Okay.
Folks online, we're gonna do this differently. we're going to ask you to record your 2-minute presentations, and we're going to put those online for folks to listen to. I'm very sorry, but there's some severe technical audio issues here. Please record your presentations after, and we'll put them online so that people get a chance to listen to your presentations. I do apologize for this, but this is what we have to do at the moment. All right, Federico, you want to go next?
Can I first ask you, can you put just a minute, the online posters? So I would just leave it there for a moment. There was from Jeremy. Yeah, there. Just as Sixui was saying, because of the technical difficulties, maybe we leave the posters for a minute so you can have a look. And then the people will record their 2-minute presentations and you can see them, but maybe we can have a look for a few minutes.
Okay, just as a reminder, there's also online posters. So please, maybe instead of showing you the poster here, forcing you to read it online with a font that's a bit hard to understand, maybe we'll just go ahead and finish the talks in person here. And then we'll make sure that you have access to all the recordings of these presentations online. Again, I apologize for the technical difficulties here. So Federico, I think you're here.
Thank you. All right, so very quick. This is just an overview of the impact of satellite constellations on radio astronomy. The idea was just to show some of the different impacts and discuss it very briefly so that it could spark some questions from you guys. Happy to have some more discussions. What we did in the center there in very small font, I can see, is dividing the impact of satellite constellations on radio astronomy in 4 different aspects. One is the very high power downlinks that Richard was mentioning at the beginning. Second one is out-of-band emissions into radio astronomy bands, so bands protected by regulation for radio astronomy, how out-of-band emissions of these strong downlinks can affect that, the effect of unintended electromagnetic emission or radiation, and the effects of downlinks into radio quiet zones, right? Zones where we are using much more bandwidth than what the ITU assigns to radio astronomy. And then on the right, there's some of the techniques that we use, for example, in the SKAO to try to understand what will be the statistics of the very strong RFI that we will receive from satellites, of the very strong signals. And what we do is we plot these density maps in the sky, trying to see what's the probability of having a satellite very close to the beam of the telescope in different positions in the sky. And that allows us to understand how likely it is that we will receive a very, very strong signal that can probably saturate the receiver or not, right? So this is some of the techniques. Thank you.
Hello, I'm Harry. I'm a radio astronomer at the SKA Observatory as well. I'm part of the Spectrum Management. Next slide. Yeah, so my poster is about a software tool we're developing at the observatory called Scepter. So basically, following what Federico just said, we're trying to do this simulation based on the TOEs that the SatHub is collecting and trying to simulate where are these satellite constellations are in the sky when we're observing, and what is the radio interference impact to our observations at any given time that we want to observe a patch of sky. So what we consider is basically the beam patterns of the transmitter and the radio telescopes, our own telescopes, and we try to calculate what is the realistic flux levels that we're observing from our telescopes from these interference sources. And that picture there is basically a 100-second simulation of 500 Starlink satellites on the sky when we're observing from the Meerkat telescope location in South Africa. So the software is open source. We're looking for people to contribute and develop as part of the Sat Hub. And yeah, come and see my poster. Thank you.
So, hello, I want to present something we call an active avoidance strategy for VLBI scheduling. So, what we are doing is, or this is something we are working or experimenting with in the IVS, the International VLBI Service for Geodesy and Astrometry. In our VLBI sessions, we have a little bit of flexibility in terms of scheduling because we're observing something like 100-200 sources per day and maybe collect something like 2,000 scans. But we have this bit of flexibility, and therefore scheduling becomes an optimization problem. So what we can do now is we roughly know where the satellites are or will be, and we can add this information as a, let's say, a boundary constraint on our optimization problem. So basically every time we schedule a scan, we simply look at the orbits and we look where the scans are with respect to telescopes on the sky. And then we simply only schedule sources that are a certain distance away from those satellites. That's the basic idea. It's very simple and straightforward. We implemented it in our scheduling software and we are now experimenting a bit with it. I did on my poster run some simulation how this boundary constraint affect our products, like our in Geodesy and also astrometry. So if you're interested in that, then please come and have a look or talk to me. The poster session is already over. Yeah, so the conclusion is that up to a few thousand satellites or several hundred, few thousand, we don't see a big impact. For a very large constellation, this will not work very well. That was everything already, so thank you.
Hello everyone, my name is Boris and I'm from SCAO, and I wanted to present you a small SatHub project we've been working on. May I ask for the next slide, please? Thank you. So we've been developing a dedicated database for radio astronomy stations that could be used for sharing and compatibility studies done within the CPS by radio astronomers and satellite companies together before entering some more official international framework. It is a digital SQL database that we expect to be distributed via the CPS website as more or less open sourcely SQL.db file. And the main sources of our data are an official master international frequency register from the International Telecommunication Union, which is the most official register you can get in the world. Unfortunately, it doesn't contain all radio astronomy stations because it's up to national administrations of each respective country to decide whether they want to make a submission or not. So some telescopes are missing. That's why we have also a supplemental source of data as Wikidata, as more or less reviewed by the community source. Of course, we are going to review it on our end as well. And you can see on these pictures is a tool that we have developed to process this data. So on the top right, you can see the map of radio astronomy stations that are registered in the ITU. Some of you might see that, for example, the Ghana telescope is not registered because you see absolutely nothing in the middle of Africa. I guess we'll need to try to contact them to help them with that. But actually, there is quite a few telescopes, unfortunately, missing. So what we are getting on the bottom left, you see the basic data of it, coordinates, and if you go there, you'll see extra data. And on the right, it's just processing, linking Wikidata and ITU files. So we are going to develop this, and I hope we'll be able to share it with you later this year. And I guess that's it. Thank you very much for your attention.
Thank you. So the next talk is by Mike Peel. Mike is online, but he asked me to summarize his poster, and I think he severely overestimates my background in cosmic microwave background experiments, but I'll try to do my best here. So as you may or may not know, ground-based observations of cosmic microwave background, which is basically the light that is still here from the origins of our universe, is a really, really big enterprise. And there is also some multi-billion-dollar projects currently being developed that are trying to understand our origins in very, very early times of the universe. Now, at the moment, the frequencies that the satellite constellations are using are reasonably well separated from the ones that are used to understand the cosmic microwave background. But that may not be so in the future because, for instance, Starlink is now already pushing a little bit to a higher frequency, maybe even use the range of 120 to 170 gigahertz. And this is basically where most of the cosmic microwave background experiments are happening and where they are mostly observed, just because there's a galactic emission that people want to avoid as well. And so this is something to really keep track of, even at the moment with current projects, just as the Kishot MFF2, they already can see some of the Starlinks, and future is completely unclear, and their impact on the cosmic microwave background experiments is also unclear. Thank you. Then we have Hamid, who I think is also joining us online. So maybe we can skip his slide for just a moment. Ayub, are you here? Also online? So we'll skip you as well, I'm sorry. Cantigrel? Also online, sorry about that. And then we have Abdul Karim maybe, also probably online. All right. So that was a very, very quick session, much quicker than I was expecting. Again, like I do apologize for technical difficulties, and don't think that you are not going to hear what these excellent people have to say. We're going to ask them to record and put this online also on hopefully the CPS resource where you can go back and watch this later, even maybe perhaps after the IAU. So, with that, I am extremely happy to open the discussion and question and answer session. So if you had questions to the speakers that you've seen so far, please go ahead. You can post them now. We're gonna also track what people were putting online, so don't worry about that. Any questions for any of the speakers? I would also ask the speakers maybe to come to the podium, questions directed at them, and try to answer those. Questions? Please. And please be kind enough to wait until the microphone arrives, just so that folks online can hear you as well. What was that?
Oh, sorry. Did I hear you say you wanted people to come up to the podium?
Oh, just the speakers.
Yeah.
This question is for Richard, or really for any of the experts in the audience. We heard earlier that the number of satellites are now at 10,000. There might be. Okay, so you can hear that? Okay, very good. And then we heard projections of 100,000. We heard perhaps talk of 1 million. We heard from Željko that if it's just at a few tens of thousands, it's a nuisance. But my question is, what limits the total number? There is the desire to go beyond satellite internet, to go direct to cell phone. There's a lot of money being made, but at some point it will just become a demolition derby of all the satellites will collide with each other. So are there any reasonable estimates based on the business model and sort of orbit occupancy of where we think this is going to wind up? Because it's going to be more than tens of thousands, but Can it really be 1 million? What's your best guess as to where this is going to land and on what basis?
I will immediately say, I can't answer that question quantitatively, but there is commercial pressure. That is absolutely true. The trend that was exacerbated by Ukraine is that militaries were originally thinking that they would love to contract to commercial entities for their space surveillance programs. And when they realized that, yes, a company's under contract to you, but they can also decide to do something else because you aren't actually their boss. Most of the individual militaries are now planning constellations of their own. So the pressure is not only bandwidth to make sure you get your videos while you're flying over the Pacific, it's that each national government wants a constellation of relevance to them that they can control. When Elon Musk tells us that space is infinite and that's an infinitesimal point, so there's unlimited carrying capacity, that's true only in the limit that you know exactly where your satellite is at every moment. And then Marie Vajah could be here and tell you that even the stochastic uncertainties of variable friction of residual particles at altitude makes that prediction not accurate enough. So in the US, the FAA, when they license a launch, asks the operator to run a kind of basic software estimator that NASA provides, and it's based on current traffic. So they have to show that they can control their satellite sufficiently well to avoid collisions in the current traffic environment. What they don't do, it's not a very sophisticated program to begin with, and they don't require a future estimate with an exponentially increasing number so that 5 years from now, that level of control and positional knowledge is adequate. So that's a problem. And I will, I think, defer to people who know better than I who want to add to that answer. Okay, I'm done. Yeah, the basic challenge is nobody believes the 1 million number, and the ITU is trying to tighten the limits on what they call warehousing, where you claim orbits and hope that you'll sell to a customer the right to use that orbit. And so the 1 million is unlikely, but many tens of thousands is almost a certainty. And so there is this question about carrying capacity, and that's where the IAU wants to join forces with industry, just because that is sustainability. You just can't have demolition derby, and you have to be realistic about what carrying capacity is. And the Outer Space Treaty talks about equitable access for countries who may not be spacefaring at this moment, but might be in 5 or 10 years. Is there any capacity left for them? So there are serious policy issues as well. So I think you've brought up a key question that needs serious consideration for sure. But anybody else with thoughts on that?
Thank you very much. Maybe just to add a little bit, because we've been working closely to this topic in ITU together with Federico. And what I can say to you is, and maybe some people might hit me if I'm wrong, but I think we already have more than 1 million, at least, paper satellites filed in ITU. Some filings are really tremendously high. For example, there is infamous in spectrum management filing made by Rwanda for 400,000 satellites approximately. Can you imagine that constellation? And of course, they have to register it because it's coming from country, they can't doubt it. So that's one side of the problem, that we have more and more submissions, and we have absolutely no control on how to predict whether it would be a real satellite constellation or it's just warehousing, they're just keeping it for the time being. And it's the first issue. And the second issue, because I think what Richard mentioned, what FAA is doing is really good, but unfortunately the problem is that it's one country, and satellite operators, when they are not really happy with the regulations in one country, what they tend to do, they just go to another country. They go to another administration which is much more flexible, let's say it's that way, on how they're going to launch the satellites, how they're going to authorize. Then they launch it without all these restrictions. So just wanted to maybe add a little bit that in order for it all to work, it shouldn't be only just one country's effort, but it should be a global effort. Thank you.
Just a tiny bit on the numbers. I think the biggest push on the numbers comes from the space industry and the space sustainability, thinking about debris. Right? It's not from the astronomy point of view. Right? We care about that a lot, but we are not moving that discussion. The discussion on space sustainability is a very big one, which Dark and Quiet Skies luckily is part of it, but the biggest one is on space sustainability from the point of view of debris, and industry is very concerned about it, or at least they say is very concerned. So I think Richard's numbers are in the ballpark in saying that we might expect something in the order of a few 100,000 satellites. That could be a realistic number. But the challenge here is that, as Boris was saying, the regulation of the physical use of space is not clear. There's a very clear regulation in the use of the radio spectrum in the ITU, but there is not a very clear use of the physical space. And that's a big challenge that mostly industry trying to use the physical parts of space are concerned about. We luckily are part of the discussion, but we are not driving it.
Hi, James Lowenthal from Smith College in the United States. The satellite companies have, in many cases, for example, SpaceX, committed some significant resources to trying to mitigate the brightness, and in some cases have gone to significant lengths to accommodate the ITU radio regulations. But in no case that I'm aware of have they reduced the number of launches or satellites, either launching, operating, or planned. So thinking ahead to the long term, it seems inevitable that these numbers in this plot will continue to rise at a probably ever increasing rate until, I don't know, the carrying capacity or the demolition derby or the Kessler syndrome or full coverage of the entire globe. We don't know what the number will be. But it seems that in the long term, perhaps our strategy should be make sure that they will come down by themselves. And I know that we astronomers have pushed for lower altitude, 500-600 kilometers where most of the Starlinks are. But we just heard that China launched its first Starlink-like constellation test at 800 kilometers, where the orbital decay period is on the order of 50 years. I don't know if those satellites are required to come down or not, but if they aren't required to be brought down actively, then they're up for 50 years. And if they lose control of any of the satellites, they're up for 50 years. So is it a long-term strategy? Is it a reasonable long-term strategy for us astronomers to say all the satellites should be at a 10-year timescale altitude, which is whatever, 500 or 600 kilometers? Could that be our long-term strategy, that we give up on trying to limit this number until the technology changes and satellites are no longer required, something like that? But at least it would be self-limiting. Is that reasonable?
for the purpose of stimulating discussion, I'll give a couple of answers. We would love it if the world actually adopted the precautionary principle of environmental law, saying, hold back a little bit until you understand what the impacts are, because the counterpoint to that is the atmospheric chemistry of burning up that much exotic material at that rate. And so if we're depositing alumina and silicates into the upper atmosphere, are we seeding stratospheric clouds? Are we doing inadvertent geoengineering? You know, do we really want to demand a quick burn up of everything, or would we like to at least run some simulations to know it? But if we go that that's still the best disposal method that we know, then you have I would ask your question in a little different way, which is, you know, FAA licensing, and we would like, as Boris said, to get other countries on board with a consistent system of licensing for launch. You have to demonstrate that at your end of mission, you have enough propellant and control or whatever it is to re-enter on a prescribed timescale. And so I think what you're asking, rephrased, is what failure rate do we tolerate? In other words, how many of them, you know, if they're designed to re-enter on command, you know, then the ones that won't are the ones that fail. And how many could you tolerate tumbling around in orbit for 50 years? So, you know, can licensing agencies ask for reliability studies as well as just assertions that they have enough fuel on board? It's a really interesting question. But again, Federico.
Thank you. Can I ask a question?
Maybe just a comment on the ESA.
Yeah.
Is your degree? It's okay, I'm here. Just a quick comment on this question. I think it's a very, very important question to understand, like, who are the regulating agencies and what can they do? And the European Space Agency has currently a program in development that's called their Zero Debris Charter. I'm pretty sure you've heard about it. And there, even there, you know, European Space Agency is not a small agency. Even there, they have to take the approach that they want to invite industry partners, you know, to discuss in common, like, what are tolerable risks, what are tolerable or feasible approaches to this mitigation. And at the moment, they're only focusing on technical solutions that they can then promote through their partners with industry and through their new contracts. But the regulation is a completely different ballgame. And this is, I think, where we have to be aware that this needs also extra effort. And I hope at the CPS we have discovered through the Policy Hub. And we're doing what we can, but it's really a community effort where everybody has to do their part and to make sure awareness is raised. Just one question. I'm so sorry, Federico, but there is a question online, and I think it was for Matthias, namely, if we go and back to your slides and look at these kind of avoidance strategies for VLBI, how many satellites do you think you can tolerate actually?
There we are. Yeah, that's a good question. So this really depends on how many sources we have and we can consider, because we have this optimization problem that I discussed about. The more satellites we have, the more of the sky we have to block out, so the more limited we are in the end. So, and this is of course different for all the different telescopes that we have around here. So from our current point of view, I think I did not see anything dramatic. Maybe 20% of observations are infected if you don't do any. Worst case, if you go to 5,000-6,000 satellites, something like this. It's very hard to say how this will affect our results in the end. If we only have a pool of 100 sources that we would like to schedule, it might have a bigger impact than if we have a pool of 300 sources we want to schedule, simply because with the 300 sources we have a lot more flexibility in our optimization. So we will always or more likely find something that might not be affected in the end. So the short answer is maybe few thousand, I think, is a good estimate. And also from the software point of view, of course, it costs it costs something to run all this optimization in the background, but also there having few thousand satellites, it's more or less negligible. But if you go to the tens of thousands, suddenly your software runs 3 times, 4 times, 5 times as long, and then you get into problems in the end. So that's hopefully this answers it to some degree. Yeah. Okay.
So hang around. Yeah. How many satellites is that for, the far right plot, which is sobering?
No, that's just some simulations we did. So we just he assumed this was like 4,400 or something. I would have to look at my poster to get the exact numbers. We also did some simulations with 32,000 satellites. So this is the scarier plot, but you don't see anything anymore. It's all red, so I didn't put it up here. So
I have a follow-up question on that. So you're showing this. Have you implemented it and made observations with the scheduler, or is it planned?
We have implemented it, so it's currently in the scheduling software itself. It's been there for a couple of years already. We are not operationally applying it at the moment, simply because that's mostly for VGOS, so the next generation VLBI system for the IVS. And there our feeds we can observe from 2 to 14 gigahertz roughly, so that was the specification. But at the moment we are only observing from 3 to 11, I would say, simply because of 5G from the bottom and the satellites from the top. Not everything is there. So at the moment it's not a concern at the moment, a big concern. So we're not doing it operationally at the moment.
So one final, very technical one.
Yeah.
What's the angular separation you're using as a constraint on this?
Okay, yeah, that's a very good question, because I don't know the answer. What's reasonable here? So what I did in the simulations, I simply had 2 things that I'm doing. First is an error for the orbit propagation. We are operating based on TLE files. They have an accuracy of maybe 1-2 kilometers at epoch 0, and we usually make a schedule 7 days in advance. So this propagates 7 days in advance. Suddenly you are at a 10 kilometer error or something. So that's one part of this avoidance area. And then for simplicity, it just added 1 degree on top, because I mean, if you look at the feed of the field of view you have. I mean, I'm not concerned so much about the side lobes, honestly, because we're doing very long baselines. So I'm more concerned about saturating the receivers and all this stuff. So I hope this makes sense.
Yeah, thanks. It makes a lot of sense. It's something similar we're looking for.
Okay, good. Thanks.
Sorry, but you might as well stay here just for 1 second before we move on. I'm sorry, Jessica. This is actually a question to both Federico and you. By Robert Massey, who was exactly asking that question. So are the current TLEs good enough to enable, radio astronomy to do these kinds of avoidance? What kind of accuracy would you wish that people give you in terms of satellite positioning so that you can do your job?
Can I try first?
Yeah, go ahead.
Right. So I would say, depending on what you're looking at, if you're looking at saturation of the receiver, maybe it's okay for most of the radio telescopes where you're looking at a single dish and the beams of radio telescopes are fairly large, right? You get very large radio telescope, but still the beam is not in the order of arc seconds. I've been talking to some of the optical colleagues, sorry if I'm saying something very wrong, but I think one of the highest concerns is more on spectroscopy, where you're looking at fibers that can have arc seconds. And if you want to know that very, very precisely, then you need that kind of accuracy, which I understand with TLEs is very difficult. So I think for radio astronomy, if you're looking at things like Matthias and I are doing, you're okay, sort of. We did the observations with LOFAR, and we used the supplemental TLEs that we get from Celestrak or Spacetrack, and those work well. We had to adjust them a little bit, but they did work well.
No, I think you covered it perfectly. So I think it's, so what I'm also trying to propose, what I see more problem in our community in the IVS, so we have some rules or guidance that I need to make a schedule 7 days in advance. So that's a limitation, and I think it's unnecessary. I think this comes back from maybe 2 decades ago where telescopes are operating differently. So I think if we can go down to only predicting the orbit 1 or 2 days or something, it will already help, and then we are sorted.
Yeah, sorry, you're right.
Yeah.
I forgot about that part. So what we did with the observations is we tried to get the most recent TLEs.
Yeah.
Right? If you do something like I get the TLEs from 10 days ago, you get something very bad. Like you have to do stuff like Matthias is doing, like enhancing the uncertainty of where the satellite is, and you end up with the whole sky covered because you really don't know.
Good. Thank you very much. Thanks, Matthias. I think there was a question.
I'll just make a comment and pass it to Jessica.
Thank you.
Thank you. To your point about the demolition derby, I mean, it's not just in orbit, but in the reentry, as Richard was saying, and also at the launch sites. I mean, the FAA just approved some 25 Starship launches in Florida a year, which was already under a lot of legal trouble with local communities, and it's really challenging. And with thanks to our past president, Kelsey, for signing off on the Zero Debris Charter. Thank you for the AAS. So yeah, thank you. Truly, but it's really a mess. All these agencies charged, even within their purview of monitoring this, it's really challenging. It's messy at launch, messy in orbit, and messy re-entering. So if we could just advance more intentionally and precautionarily, I know that's not a word, but but we're not doing that. Thank you.
So the question I had is for the management team or anyone else who has more detailed comments they can offer, but just like a lot of what we've been discussing so far is more like the numbers of the satellites, which has its own set of issues. But like what I was wondering specifically is in regard to satellites that stand to be significantly brighter, and particularly like there's a lot of talk about, oh, well, we'll put these big solar panels in space and we'll have green energy and beam it down to Earth and that type of thing. And we're talking extraordinarily huge and bright objects. So I was just wondering if anyone could comment on how strategies for addressing those type of satellites may differ, and like what type of effects that would have on different areas of astronomy, and how that would be more or less difficult to compensate for.
Okay, so I'll start. And the good news, the quarter full glass in that situation is that those giant ones like the Bluebirds from AST Space Mobile, they're counting in the low hundreds rather than by the tens of thousands. So at that level, with about 5% of any constellation visible above the horizon at any given time, it's just messing with your observing schedule. You can't point at them. They're painfully bright. And even if they put on a wonderful SpaceX-like coating that cuts the brightness down from a factor of 50, you're cutting it down from 0 to minus 1 visual magnitude. And so they're still going to be bright, naked eye objects, period. But you can avoid pointing at them. So if you ask how professional astronomers are going to mitigate that, we'll just have to know where they are and avoid them. Are they going to change cultural heritage? Are they going to confuse wildlife? You know, there's a much broader set of issues with those that I think has a bigger impact than our workarounds, which are just going to cost us a little bit of time. But others are welcome to comment on that.
Somewhere between a comment and observation, and I'll try and squeeze a question in, but we're in a room full of scientists, and we tend to be rational operators, and I think we're dealing with what is somewhat an irrational field here. We've seen the cost of delivering things to orbit go down. We've seen the cost of satellites go down, the size go down, while people are throwing money at this. I always have in mind the cities that were dealing with those e-scooters. Anyone live in one of the cities that were flooded with these e-scooters that came into the market, then were dumped into canals, and the regulation came in afterwards? So rationally, we might end up with 100 or 200,000 satellites once this is all settled down, but I think we should be planning for a peak that is much bigger than that. I think we should take them at their word that they have 1 million constellation satellite, planned for launch and licensed there, and we have more actors come on the field. So I think, like, how does this as a professional society that's grounded in science stick to that whilst also honor the irrational aspects of this and be planning for the worst case here, whilst ultimately it might settle down? I think that is probably one, for me, is one of the challenges in this space. And as Richard said, how do we move it beyond the professional observers? I have no doubt that the professional astronomy community will figure out how to solve this and keep their science going, but that doesn't mean we've solved it for the rest of society.
Just some quick online comments. Connie, were you going to mention your comments?
Yeah, the concern also is that it's not just with the United States, it's with many other countries, and that's really hard to set regulations for many other countries when you're, taking it from the viewpoint of just the USA. So that's a big concern. That's where, the UN comes in, but that's a very slow process, so.
Yeah, that's exactly Jeremy Online's point and Tesne's point as well. So it's okay if there's a few companies like the Bluebirds doing this, right, and it stays in the low hundreds. But once everybody starts doing this because one company can do it, so everybody can do it, then it starts to become a bit more tricky, I would say. There was also one comment by Jeremy before. He was saying that with the current number of Starlinks, we see around 900 that are visible about 30 degrees elevation from the ESO ELT site. If we increase this to 500,000, that equates to over 20,000 visible, per twilight hour. And if your imagination, can't deal with this huge amount of numbers, I would urge you to check out, we have a VR headset that kind of displays what a sky with 300,000 satellites look like at the CPS booth. It's also here. So if you're interested to get a first-hand expression of what the sky with many satellites looks like, just meet me at the table behind in the break, or go to the CPS booth where we have that. Sorry, I didn't want to cut down the discussion yet. Was there, Frederick, you wanted to say something?
So I have a question out of ignorance for radio astronomy colleagues. To what extent do harmonics enter into the power that's closing off frequency space, and are they modeled in?
Yeah, thanks, Richard. Hi, this is Kelsey Johnson, and one of the hats I wear is I sit on CORF, which is the Committee on Radio Frequencies for the National Academy, and we are actively preparing for the next World Radio Communication Conference, which is coming up. And one of the things that we do actively is with every frequency that is on the agenda, we work through, well, first and foremost, what the science is that will be affected, whether or not it falls in a protected band, which is, of course, the minimum of things, because people know to try to avoid the protected bands. But what they don't do, and we get a very hard time having people recognize, are harmonics. And this has been a long-standing problem. We've had, people have had to take formal positions that harmonics don't exist, which is ridiculous as a scientist, right? Like, of course harmonics exist. And in general, though, more to the point, and I know this isn't precisely what you asked, but is perhaps an even bigger issue, is out-of-band emissions, which companies, to speak frankly, even though we're online and being recorded to the world, do a terrible job either modeling or fessing up to the true out-of-band emissions that are going to hit. And this is a really big problem for the protected bands. We routinely see really high-level out-of-band emissions. Right now, for WRC 27, we're looking at proposals to come right up against the protected band for the 21 centimeter line. And so we're trying to take a very hard stand on protecting for out-of-band emissions there. But both harmonics and out-of-band emissions are very much on our minds. And we do try to model for them, but the companies do a terrible job and we can't get either of these things really recognized.
Yeah, thank you very much. In case in point, Mike Peel Online says that the South Pole Telescope sees the 10th octave of some of the intended emissions in their data. So it's already here.
Yes, if I may comment quickly on that. There was a huge discussion in WRC 23, the one that happened last year, World Radio Communication Conference, where people didn't believe that a balloon up in the sky using 700 megahertz could impact the 1.4 gigahertz band. And it was a huge fight to try to convince the ITU of that, and at the end, we couldn't. So the ITU couldn't recognize that, but there was a workaround where that band would not be used for a downlink of these balloons, right? So that's where the ITU policy becomes very complicated. But as the colleague was saying just now, there are lots of agenda items in the ITU which are proposing satellite downlinks in bands that are very close to radio astronomy bands and others that are harmonically related. And the challenge is that normally the ITU has been looking at interference into radio astronomy from the horizon, right? So we have always been thinking about the cell phone towers so far away. We need them as far away as possible, so we put our radio quiet zones and we try to keep them away and so on. But the reality is that if you just put a cell phone tower on a satellite, it's a very much different problem. And that's a challenge that we need to address in spectrum management in the ITU.
Right. Are there any more questions? We are almost at the end of our session. So if you have something burning on your mind, now is the right time. Yes, there's one more question, please.
So this might be completely out of ignorance as well. So satellites use star trackers. Have we attempted or done a feasibility study on if we could use star tracker data to fill in the gaps that are caused by masking, just to the general audience?
Sorry, I don't think I got the point. So you were saying you want to use star tracker data to do?
No, so have we looked into the possibility of using star tracker data when the satellites pass over to see if it could actually fill the gaps caused by masking?
Oh, so I think if I understood the question correctly is, since a lot of the satellites, they do have star trackers on board, can that data that the star trackers record kind of make up for some of the lost data on the ground-based telescopes? And maybe it's a bold answer that there's no way, because the star trackers, they usually have like 10 centimeter apertures, and so they only see the brightest stars. And we are talking about, you know, like 8 meter, 30 meter telescopes, and the light that they collect are really like, you know, going down, you know, to I think the magnitude difference is about like 20 or so. So it's a couple of orders of magnitude fainter. And while this is a very great idea in principle, I don't think this makes up for it. I'm sorry. Thank you. Any other last minute questions? If not, then I would really like to thank the speakers for today. Thank you so much. Again, my greatest apologies to the folks online. Please do record your talks. We'll make sure to make it available to the community. And please do have a look at the posters. They're really excellent. So thank you very much. And we'll see you after the break for the CPS second part of the session. Thank you.
Hello, can anyone in the room hear me?
Yo, Mike, are you there?
Hello. Yep. Can you hear me?
Mike, are you there?
Yes. Can you hear me? Hello. Testing.
Mike, you there?
Testing, testing.
Okay, I'm going to drop him a Slack, see if I can get hold of him.
I'm here.
Mike, can you hear me?
Yes, I can hear you. Can you hear me?
Sorry.
Hello, hello. Can anyone hear me?
I can hear you,
Hi,
Mike.
Mike.
Okay, great. Thanks,
Can you
Jeremy.
hear me?
Yes, can you hear me?
Yes, I can hear you. I want to just see if I can hear you in the room.
Okay. Okay, good. Thanks, Jeremy. Yes, can you hear me? Ah, there's the echo.
So at the moment, we're still getting a quite significant delay. We're just going to see what happens when we talk. Give us a second.
Okay.
Yeah. Sorry. Yeah, can you
Okay.
try talking, please, Mike?
Hello, hello. Can people hear me okay?
Yes.
How about in the room? Hello, the room. Anyone there?
Is he talking? Can we hear anything?
Can you hear me? Hello? Hello, the room. I feel I should be reading a book or something, a novel. So I'm always talking, so I don't know what else to say. Testing, testing. I'll just keep saying things every so often. Testing, hello. Hello, testing. Testing, testing. Testing, testing. Ah, there we go. Just very delayed.
Yeah. Okay, cool. Talking 1, 2, 3, 1, 2, 3. Mike, can you talk for us now?
Yep, talking. Can anyone hear me? Is this okay? Testing 1, 2, 3, 4.
Thanks, Mike. You're a star.
Is it working okay?
Yeah, we've got it. I think it's one of the laptops.
Okay.
Speaking 1, 2, 3, 1, 2, 3. Testing 1, 2, 3. Mike, can you talk for me again? Sorry, mate.
Talking, talking, testing 1, 2, 3.
Testing 1, 2, 3.
Hello to the room.
Testing 1, 2, 3, 1, 2, 3, 1, 2, 3. Sorry, Mike. I think we might be there.
Hello, room. Anyone hear me there?
Okay, we think we've got that, mate. Thank you.
Okay, great. Oh, there was a delay again.
Yeah, there is. It's still here.
Yeah. It's very delayed.
Testing 1, 2, 3, 1, 2, 3, 1, 2, 3. Sorry, Mike, just I think we might be there. Everyone's sitting there. Okay, we think we've got that, mate. Thank you. Okay. Oh, there's a delay again. Yeah.
That's bizarre.
Yeah. Sorry, Mike. Can you speak for us again, please?
Testing 1, 2, 3. I can see Siegfried now. I think I do need to head off in a few minutes, unfortunately.
Hi, Mike. Can you speak for us again? I'm really sorry, mate.
Testing 1, 2, 3. Testing. Hello.
That's now coming through instantaneously, like it should
Okay,
do.
great.
Just got to make sure it comes to the speakers now. Give us a second.
Okay. I'm going to start packing up back and hang around for a few more minutes. I'm supposed to be to another conference at the moment.
You are the most patient man in history right now. You said the same thing about 800 times, so thank you.
I'm good at repeating myself.
Yep. Speak for me, Mike, please.
Testing 1, 2, 3. Testing.
Mike, can you sort of, do the
Yep.
thing again?
Testing 1, 2, 3.
It's not going to sit there forever. You're fine.
Okay, I'm afraid I really do need to go now, so I'll try to connect again for the next session a bit early. Bye.
Mike, if you're still there, can you talk for us, Mike? If you're still there, can you talk for us, Mike? Which means that when I'm talking, the next person speaks, and the next person speaks back to the first person again. So it means when someone's talking, you just get massive overlap. So my question, why is there a delay that big on Zoom? I'm not sure he's still there. We ask Mike, he's still around? Still around or not? So we have to give Mike, you have to give us a second for Siegfried to come. Yeah, we're going to sort that. So Siegfried's going to do that in about 5-10 minutes when he's downstairs.
It's okay. Two. Are you getting it? Two. Oh, it's muted. But that's a speaker though. When is a speaker? My mic in the not in the four as one now. Mais oh écoutez pas nanga eza ya kofungama yango nde naosalela
normalement
fungola na fine it's fine leave it open go with this thing outside go speak
1 2 1 2 Martins
Zola
Yebo, can you hear me? Yebo. Yes. Okay, I'm coming out now. Oh, Martins, I'm going out into the foyer. Yeah, keep talking.
Now I can hear you, it's fine. You can come back, bro.
Martins.
Okay, folks, I am online here from the booth. Can you folks hear me? Hello. I'm taking over for Mike, who is kindly free to go to lunch. I may be muted. What was that? No. Sorry. Don't worry. I was muted before. Hello. Can you folks hear me? Hello. I'm just gonna keep talking here.
You fixed the audio?
No, not yet. We are. Hello, can you folks hear me?
I have another.
I'm gonna to continue the chat now
I have this back here.
so that you folks could hear me and try if the audio works better like this.
So that's why the next thing.
Hello. I see that you are recording. Hopefully you can see me speaking as well. I am currently muted, but that's okay. Okay, so you can't see me, that's fine. Hello. Maybe I shouldn't be down here. Probably it's better if I'm up there somewhere. So that the connection go in and talk to you guys. Okay, let's see. I can hear music now.
Yeah, but we actually sorted. Yeah, thank you so much. Yeah, wait. Can you hear me?
Yes, I can hear you, and you can hear me too, I hope.
We can hear you clearly, yeah, properly. Thank you so much, sir.
Okay, perfect. Thank you very much. I'll see you in a few minutes. Bye. Thanks.
Yeah, thanks, sir. Thanks.
we trade with Exness. We stand tall while others crumble, confident in a broker who's as strong as you are. Trade with unmatched financial security. Exness, born to trade.
When your body needs extra immunity support, Centrum's new immune support is there for you. Nature meets science to help support your immunity. You did it.
Hey there, this is Andy Williams here. I just wanted to check that you can hear me in the room.
Okay. Can you hear me?
Yes.
Can you hear me properly?
Yeah, loud and clear.
Oh, okay, thank you so much, sir. Appreciate.
And I'm going to share my slides right from Zoom.
Yeah, cool.
Okay.
He's gonna share, yeah.
Hello, Andy.
Hi.
Andy. Hey, are you sharing your screen or we are sharing it?
Yeah, I can share my own screen.
Okay.
Good to go.
Yeah.
And hi, this is Sam Lawler. Can you hear me talking?
Yes. Hello. Hi.
Hi. Okay, and I'll just share my screen also. I'm at the very end.
Yes. Yes. And Yana
Okay.
is all there.
Oh, can you hear me?
We can hear you. We can hear you. Are you
Okay,
also
cool.
sharing your screen, right?
I'm also going to share my screen. Yes, thank you.
Thank you. Tamara, is it there? Are you there? No yet. Okay.
Tamara is not here yet.
Hi, this is Beatrice.
Hello.
So can you hear me properly?
Yes.
Okay.
Can you hear me properly?
Yep.
Yes. Great.
Yes.
Sharing your screen, right? We're gonna do
Yeah,
that.
fine to me, yes.
Fantastic. Great. Thank you, guys.
So Andy and Sam, with your sessions, will you be following questions in the chat here as well?
Sure.
Okay. Because we have a few different places. We've got the YouTube chat, we've got Slack, and we've got here plus in person. So I've mostly been pulling them together onto Slack, but I can also copy over and see into the Zoom chat here.
Okay, that'd be great. Thanks.
Okay.
Yeah, that would be great.
Hey, Tamara here, just to check the sound. Can everybody hear me?
I hear you.
Good, thank you.
Hello. Yes, that works. Hello, everyone. Thank you so much for joining us in our policy session. Online, we're welcome people online also. Can you hear me properly in online? Yes?
Yes.
Great.
Yes.
Thank you. Thank you. Welcome, everyone. My name is Marietta. I'm also part of the CPS Policy Hub. So we're very, very happy to have you here today, again, online and in person. We don't have much time. So basically, we will have oral presentations, and we have for 5 minutes. So when you have 2 minutes left for oral presentations that are mostly online, when you have 2 minutes left, I'll let you know. And for the rest of the lightning sessions, we have 3 minutes for presentation. And I'll let you know when you have 1 minute left. So thank you so much. We will start now with the first presentation, which is Andy Williams.
Hello, good afternoon, everyone. I'm really pleased to kick off this policy session of the CPS. I'm Andy Williams. I'm currently the Policy Hub co-lead along with Aaron Bowley. So as a community, we've made notable progress, but we still lack formal government regulations, especially on the optical side. All the while, the LEO environment is becoming increasingly crowded. So just last week, we surpassed 10,000 satellites in LEO. So in the next 5 minutes, I'll provide a little bit of context for this session and emphasize the importance of supporting the development of dark and quiet skies standards in both government and industry. So a key question we have is, where can we look to find existing regulations, or how can we create new ones? Well, we have a set of international treaties from the 60s and 70s that are legally binding. These are either covering specific areas like the registration of space objects, or they establish broad principles such as those in the Outer Space Treaty. While the Outer Space Treaty contains some potential hooks that could form the basis of dark and quiet skies protections, it requires a government to implement it in a specific regulation. So it's important for us to study these existing treaties, but we also have to realize that at this current time, the geopolitical situation, we're not really in a treaty-making era, so we can't expect a new one to come to our aid anytime soon. We are now in an era, however, of national space lawmaking. So the increasing number of space actors, the growing importance of the commercial space sector to nearly every aspect of society means that many countries are developing new space regulations or revising existing ones. So we actually have quite a good window of opportunity right now to be acting on this with respect to regulation for dark skies. And this is exactly what organizations like the IAU CPS are working towards. So this slide here shows a recent study by the Deloitte consultancy, and it's outlining the regulatory landscape for space operators in the US. And it's showing on the left side the different agencies that the different regulations that space operators have to check, and then on the right the various government agencies involved in this process. So it's indicating that introducing new regulations is rarely straightforward due to this complex kind of intricate set of institutional arrangements, and as a result, change tends to be very incremental and piecemeal. Now, when we look at emerging technologies like AI, like cybersecurity, and now the space sector, we're actually seeing a phenomenon where the regulatory system is evolving to begin to incorporate more fluid sets of informal soft law governance mechanisms. So on the one hand, this is quite a profound shift, I think, for our governance, which I can't get into today, but it's also a reality that we have to adapt to and consider in our plans. So at least in the area of dark and quiet skies and more broadly space sustainability, we are seeing positive change. For instance, the United States now requires operators to enter into a coordination agreement with the National Science Foundation, and we see other agreements between operators and governments, like the recent agreements between SpaceX and the German government. And I hope in the future that the NSF and other countries will eventually share insights on how these processes of collaboration are working. Now, at the current time, there are 4 specific movements underway to develop standards or guidelines, and some of our later presenters will cover this in more detail, but the European Space Agency is developing a new standard for dark and quiet skies, which eventually will be mandatory for ESA missions. And the EU is working on a voluntary space label. Additionally, there are 2 private initiatives, the Space Sustainability Rating and the Earth Space Sustainability Initiative, which has received some government funding, but they're aiming to rate space missions on their sustainability, and it's good that dark skies is a part of this. So how do the development of these standards and guidelines help us? Why are they important? Well, first, guidelines are a flexible way to address gaps left in the regulatory landscape. And these non-binding guidelines and instruments, guidelines and norms have been used in the space industry for quite some time. Secondly, the development of guidelines is promoting continuous learning and adaptation. We're seeing this in the industry collaborations and all the work that we've done so far in the CPS and with observatories in industry. So this is really, really important, this learning. Thirdly, the guidelines can complement rather than replace hard law, hard regulation. So soft law can influence expectations, can start the process of norm creation. And I think that now we are in the process of creating a norm about taking care of astronomy, dark and quiet skies in the space sector. And I think this takes a lot of time to be realized.
Andy, you have 1 minute left.
Yep. And finally, the most important, the development of standards and guidelines can inform the development of regulation. So we've seen this with the non-binding guidelines on space debris mitigation by the Interagency Debris Coordination Committee, which have influenced national regulations worldwide. So for these reasons, we shouldn't stop raising the alarm bells, and we should continue having long-term plan for regulations, but it's really important to prioritize this collaborative work with industry and with governments in the development of these voluntary guidelines and standards. So that is my last point. Thanks for the attention.
Thank you so much, Andy. That was a very, very good presentation. I forgot to say that Andy also, he's going to be your Q&A moderator. So I just wanted to include that. Now we will continue with Jana Yakushina. Can you hear me?
Yes, hello. I'm going to share my screen. Okay, can you share can you see my screen? Yes. Okay.
Yes.
Good afternoon, everyone. I'm very happy to be here today. Unfortunately online, but I hope you have much fun in person. Today I will be presenting the final results, conclusions, and recommendations which have been developed within the National Analysis Group of IAU CPS Policy Hub. Unfortunately, due to time limitation, I will not be able to focusing on all the research questions which we have been addressing, but I will be focusing on the 4 main questions and the conclusions and give you some recommendations which we provided. So here on the map, you can see the colors are 77 countries which were under our group analysis. It's a total of 77 countries. We analyzed the existing policies, regulations, and laws, so the primarily data, to understand what is the current state of the art on the protection of dark and quiet skies in the world. Obviously, the level of the analysis in every country is pretty different. For example, due to underdevelopment of the satellite regulations or space law regulations in general. But otherwise, I think our final report, which will be hopefully released soon, provides the general and the good overview of understanding how the dark and quiet skies are protected across various jurisdictions in the world. So now our research has been conducting within the 1.5 years, and we have been focusing on the 3 main aspects. So the protection of dark skies, the protection of quiet skies, and also satellite regulations, we specifically looked into the requirements of reduction of the negative impacts such as satellite interference. And now I will be addressing 4 main questions. The first one, are astronomical activities considered an exercise of exploration and use of outer space within the national legislation? And here our main conclusion is that in several countries, space laws and policies do not necessarily designate astronomy or astronomical observations as a space activity as such, but nevertheless, this doesn't exclude astronomical observations or astronomy from being categorized as such. Therefore, the main point for us here is that we can continue to further explore the expansion of the national and international space law towards the protection of astronomical observations. So it's a good point for us here. The second question is, do countries have norms aiming for the protection of dark and quiet skies for astronomical observations? And here, 3 main points. Basically, some countries already have developed regulatory frameworks aiming to protect dark and quiet skies for astronomy. However, this trend is very limited. You can find it, for example, in Spain, in France, and as an example, the city of St. Petersburg of the Russian Federation. So here, mainly, we're speaking about the areas where the significance of astronomy has been broadly recognized. However, these measures cannot be considered as very effective. Here we're talking about the creation of dark and quiet sky zones, which not always really work in the cities. The second aspect here is during the last 5 years, more and more countries started to adopt national legislation and policies aiming to reduce terrestrial light pollution, such as Chile, Croatia, Czech Republic, and other countries. They rather not focusing on norms to specifically address orbital light pollution, though. So we're here talking about the terrestrial aspect. And then the third point is the protection of quiet skies. And here, our main conclusion is that the protection of quiet skies from harmful interference, in particular from satellites, is very limited and underdeveloped and requires more attention. The third question and the conclusion is what regulatory areas are or could be applicable to protect dark and quiet skies. And among the existing national regulations, which are obviously very broad, we found out that the primary area for legislation for protecting dark and quiet skies appears to be environmental law together with space law. Here we're talking about mitigation of terrestrial light and noise pollution, and from the space perspective, we're talking about space sustainability, space debris mitigation, for example, and other areas can be laws on the protection of cultural heritage, especially in the States, when sky or astronomical traditions are considered valuable and beneficial for their society, and the certain provision of urban planning and building laws. And here we're talking about the requirements, for example, concerning the artificial light at night. And the fourth question I'm going to be addressing today is, do countries have developed regulations and or technical requirements for satellites that could be beneficial for the protection of dark and quiet skies? And here, unfortunately, currently the national legislation on satellites is mostly undeveloped, and we looked in the countries which have participating, let's say, in the space race for a very long time, like China, Russia, or United States, but also countries who just started to get involved. And for almost every country, these regulations are underdeveloped, and they don't include the measures specifically to reduce impact of satellites on astronomical observations. So we have work to do. And now I will address some recommendations which our group came up with. The first is we need to incorporate the protection of dark and quiet skies into broader environmental. Yeah, okay.
If you can do it in 20 seconds.
Yeah.
If you can do it in 20 seconds.
Just very quickly.
Thank you.
Yes, I will. We have to incorporate dark and quiet skies in environmental concerns. We have to work towards the legal recognition of light and radio pollution, both on the ground and outer space. We have to support regulatory changes. We have to find what is the place of astronomy within the space policy and other strategies. We can continue tracking the regulatory changing, so hopefully we will continue work with IAU CPS. And we also, I think the financial support is required for this work. And my final slide, I just want to give credits to all the team. Without the team, we will not be able to provide this amazing research. Thank you very much.
Thank you so much, Jana. Thank you. We will continue with the next presentation, which is my presentation with Robert Massey. I think, yes. Hello again, thank you so much. Well, my name is Marietta, and I'm presenting with Robert Massey, who is joining online. We are both part of the CPS Policy Hub, and we are also part of the Royal Astronomical Society in the UK. Jana already talked about a few things about national policy, and so she gave me the kind of introduction to do that. So we'll be talking very briefly about the protection of dark and quiet skies, so recommendations for the decision-making process, specifically in the idea of institutionalizing the protection of dark and quiet skies. So on the one hand, we have regulation, and on the other hand, we have the capacity or the institutional capacity of countries to actually protect dark and quiet skies. So very briefly, we can see that we have stable, safe policies for the protection of dark and quiet skies. This might sound somehow obvious for some people, but it's not that obvious. So, for example, we need to understand that at the national level, this is a different context as the international level, right? So the national level, we have different set of policies that somehow address or could address the protection of dark and quiet skies. They are not necessarily addressed together because there are a different set of policies, and policies are somehow linked, no, not somehow, they're definitely linked to different ministries. And they don't necessarily interact. And this is a big issue when we want to talk about centralizing the discussion about dark and quiet skies. So depending on the country, you can find different set of policies. On the one, so for example, we can have everything that has to do with satellites. I'm talking about very in general terms, because obviously, again, depending on the country, you can find different sets. But so for example, you have everything that has to do with satellites and the development of space capacities. They usually could be related to national space policies or strategies. On the other hand, you can have everything that has to do with astronomy that usually is related to science policy, or in some cases, specific guidelines or specific programs for the development of astronomy. This could be related to, for example, allocation of resources for research, allocation of resources for universities, or for research in general. Then you have telecommunications policy, which has to do with radio astronomy, and that is somehow, well, it's very related to telecommunications strategy and so on. So when we have, we really think that identifying all this set of policy is key, because again, in order to have to address all the different issues, because of the nature of dark and quiet skies, there could be sometimes environmental issues, there could be sometimes the problem with satellites, there could be the problem with terrestrial light pollution. Then with satellites, obviously the nature of that means that they are not necessarily in a joint conversation. So the first thing that we need to do is identifying the sets and then trying to somehow centralize that discussion. And that could be done through different ways. So one suggestion could be centralizing efforts and actions through, for instance, one governmental body. For some countries, this could be, again, quite obvious. So you can have space agencies, you can have commissions that are linked to one ministry, or one commission linked to 3 or 4 ministries. That depends. But it should be really, it is a suggestion to have that kind of centralization, to basically don't have this dispersion that we can see sometimes in different situations or in different countries, where again, those policies are not necessarily interacting. Policies are different as compared to regulation. This is something that we need to do. They're part of the regulatory framework, but not the same. So policies are plans and guidelines. So in this respect, you can have, when you identify this set of regulations, you can have some kind of clear picture, relatively clear picture of what are the priorities of governments or the plans that the governments have for a certain amount of time. That could be 4 years or so on. And in this respect, also, we need to be quite clear about what we want to achieve. So we know so far that In some countries, there are regulation related to the protection of dark and quiet skies. What we know is that in general, it's more related to terrestrial light pollution. And we have to be very thankful of astronomers and environmental groups that actually they have been pushing for that. But not necessarily, as Jana was saying, what is happening with satellites. So we need to be quite clear about, we need to focus on that discussion and being very specific about what we want to ask. So then we can include that in the policies or in the discussions for the policies. Finally, this is like a bonus, but everything that has to do with decision-making has to do with politics. So we need to understand that governments in general have agendas. We know that they are elected because they promise things. This could be like the politics of space or the dark and quiet skies. So they have agendas, they are elected for those agendas, for those promises. So they try to follow those guidelines. That doesn't mean that certain groups within ministries or within certain commissions are not pushing for other ideas, but in general, they have their priorities. So aligning with the political agenda is quite key. And in this respect, I think that we have a window of opportunity when we talk about environmental issues. Because environment is a hot topic. And most countries, not all countries, but most countries are kind of concerned about environment, and they have policies for that, they have plans, they allocate resources for that. So this is a key topic. So we could definitely, as a final suggestion, we need to have more research about the environmental impact of satellites on environmental impacts of satellites in general. And I wanted to include these two research papers because I really think that they provide that kind of approach. And this is important because you can say, okay, we're not just talking about one issue that is not, that we don't have funding or we don't have financial resources to cover. This is very about the environment. So with this kind of research, we can just go and push for legislation, and we can use that that information for the decision-making process. And that's all. Thank you so much. I don't know if Robert, are you online?
I am, but I don't want to add to what you're saying, Marietta. You've done a fine job.
Thank you so much. So thank you. Thank you. Now we will continue with Tamara. Are you there?
Yes, I'm here. Can everybody hear me well?
We can. So Tamara, I'm going to try to pronounce this properly. Blagojevic.
Yeah, good attempt, but close enough. Blagojevic. Yeah, it's an itch. Yeah. So I can share, right? Just give me 1 second. And okay. So I'm not gonna use much time to kind of present myself. Some of you might know me, and it's written here. I've already introduced myself in Slack. Also, Jana, Marietta, and Andy did a great job. So I can just kind of continue and focus on how we get to making changes and how does the norm development actually come to binding laws at a certain point. So I'm going to focus on that. Let me just see how I click next. Okay. So when you see this picture, I've been posting it on Slack. I've kind of played with AI and asked it to develop its own pictorial metaphors for multiple different things. First was monkey see, monkey do. Then one drop of water as a change, meaning that every action and what we say, especially as legal specialists, or write or publish, does matter. Then the butterfly effect, and again, how an unpaved road then paved by others can create a rule in time. So here is like a depiction of Mother Nature, I think, as well. So talking about, as I say, a life of a norm, if you can see the next slide, Andy also spoke about this. This is the ICJ official sources of law, meaning things we can consider as lawyers and legal specialists. And I play a little bit here saying a baby norm stems from human behavior. it's reflecting, the reality, what we do, what we think, what we say, our customs, our behavior, our traditions. They grow from social norms and, from acceptance by others and recognition by others in repetition in human behavior. They grow into something else. They slowly grow into law. I just realized I forgot to turn on my camera. So yeah, I hope you can also see me now. Hello, guys. So what is opinio juris here? It's a official, legal consideration and opinion, for example, of a certain state towards the binding nature, the acceptance of a certain behavior or norm. Soft law and hard law, I think, was to a certain extent explained by Andy. And soft meaning those are kind of, lower level like regulations or policies or guides that slowly either influence the hard law, meaning the binding law, or it can go the other way around. They can fill in the gaps and further explain. This is not just something I said or think. This is something that also stems from what legal specialists and people who talked about the foundations of law and especially space law already spoke about. So there's some examples here, like Manfred Lach talking about the principles being couched, being made in such a general, with broad terminology. Why? Because space law is a fast developing field, and we want to let the technology and science to develop. So it's going to be mainly interpretation. Andrew G. Haley also said that natural law must be acknowledged as the prime source of law, and we should shift from only merely anthropocentric concepts of law and that kind of a view. A judge, an ICJ judge, also said that the primia principia, the general principles of law, they reveal the values that inspire the whole legal order. And the special rapporteur, Michael Wood of International Law Commission, talking about in the draft conclusions on customary international law that treaties that are not even yet in force and binding can be considered as influential in legal interpretation and understanding other norms if they're adopted without opposition. Then the Vienna Convention on Law of the Treaties as well, that talks about the interpretation as well, the meaning of treaty provisions is ambiguous and obscure. We can recourse to supplementary means of interpretation. If you look all of this, it's kind of a evolutive approach, and that evolutive approach is nothing else than like systematic and integrative approach to interpretation, meaning taking all pieces of the puzzle together. So that's why we were using the multidisciplinary lens, as both, Jana and Marietta also implied. What are behavioral science mechanisms? They have nudges and boosts. That is something that I explored in environmental sciences with particular examples. You can see that European Court of Human Rights did not have a right to a healthy environment enshrined, but it was slowly included as a additional damage in its case law, followed by a report, and then the committee started also including it in the European Social Charter. And in 2022, UN adopted a resolution, the General Assembly, recognizing the right to clean, healthy, and sustainable environment. In that report,
Tamara,
sorry?
you have 1 minute left.
Oh, 1 minute. Okay, I'm going to speed up. Good thing I already talked about national examples. So, okay. So Rio principles, they also say about integrative approaches, peace, development, environmental protection, and cooperation. This is from the previous research, preliminary research. It depends of our interpretation, how we can see or something is close to being accepted as a darkened sky area or during applications. And then when you look at national examples, I just want to say there are different approaches. For example, in Europe, due to harmonization and existing standards, there's also bottom-up pressure, and states are nudging each other, pushing each other towards regulating something. You see your neighbor doing good things, and you kind of want to develop. Egypt, Morocco, it's circumstantial, and the level of development is showed in architectural implications. For example, letting the natural light in the building. So tradition is showing the behavior. In China, for example, you can see multiple local ordinances in law, but in tradition and culture, you'll see that good neighboring behavior is something that's like a principle. So do not allow too much light on your neighbor. So they're including it in civil law as well. In Vietnam, because of pollution and traffic, that's nudging an anthropocentric, reactive, circumstantial approach. So we have a geopolitical context, economic development, social behavior, and culture. What we can do here to influence this is take into account both soft law before it becomes hard, because the concrete is for
Tamara,
soft.
try to do that in 10 seconds.
I will. Thank you.
Yeah, there you go.
So even the ICJ statute says now that we can combine two approaches and see those elements as one. And the competitiveness can convert into a collaboration. We have to be preventive and to take precaution and diligence better than remediation later on. And the sustainable development umbrella can guide us toward different areas of law to consider, like environmental law, for example. So that's mainly what I wanted to say. Thank you very much. Sorry if I prolonged. And the main point here is activism, our words matter, our behavior matters early on. So prevention. Thank you very much.
Thank you so much, Tamara. Thank you so much.
Problems.
So now we will go with Beatriz.
Yeah.
Are you there? Yes?
Yeah, I'm there. Yeah.
Thank you.
So I will share my screen. Okay. Can you see it? Yeah. Okay. So yeah, my name is Beatriz Gilete, working in ESA Space Debris Office. Together with my colleague Jan Szyminski, we are both involved in any aspect of dark and white skies needs to be taken into account. So the aim of my talk is to introduce you with the recently requirements added to the new publicly ESA Space Debris Mitigation Standard related and applicable to dark and white skies, and how ESA intends to verify mission compliance to them. So since 1990, several efforts have been made. I'm not going to go through all of them in detail. To highlight just the latest one, so ESA adopted the zero debris approach, and then we public the update of the ESA space debris mitigation requirements, and it remains as the baseline standard together with an update on the ESA policy. Currently, we are now going through the process of publishing the associated handbook, which basically is going to provide guidelines on verification methods and possible implementation of mitigation measures in support to ESA missions. And for the first time ever, a specific requirement to dark and white sky have been introduced in these technical requirements of the space debris mitigation guidelines. So the rationale of those were covering three aspects. So limiting the optical and radio frequency interference of the space object with ground and LEO astrometry, informing the mission design of the brightness and promoting mitigation actions, in particular for large constellations, and enabling the protection of radio astronomy observations and radio quiet zones. So the first of the requirements actually apply for both, so to dark and white skies needs. And the main objective is that we are obliging now the manufacturer, developer, and operator of a spacecraft to share data, to make them available the data. So they can cover, for brightness data, antenna diagrams, orbital profiles, current and plan maneuvers, and not only orbital, but also attitude information. So the way that we intend to verify that the mission is complying with that is via two means. So the review of the design and analysis. By means of the review of the design, we need to ensure that the ground segment of the associated spacecraft will provide, it has capabilities of provision of precise orbital and attitude data. Also, we will review the CONOPS to ensure certain capabilities on precise orbital and attitude data, switch off or pointing away over a radio quiet zone capability, but also on surface material optical properties collection to make available brightness properties of the material used, and also surface material optical properties. And by means of the analysis there, the satellite needs to demonstrate that it has attitude maneuverability capability, and also we need to identify the antenna diagram it will produce. The next two requirements apply only to dark skies, and both of them are exactly the same. Essentially, one is for one single satellite mission, and the other is for a constellation. But in essential, we are putting a limit on the visual brightness of the spacecraft. So, of course, this is the well-known formula provided based on the Vera Rubin Observatory needs. And there, the way we intend to verify that actually they're compliant is by means as well by review of design. So there, the idea is to identify which systems are prone to have specular reflections, and if there is any materials with high reflectance properties materials. And then we ask them to actually assess the brightness during since the beginning of the design of the mission. So in the early phases of the mission, it can be done based on primitive shapes of the satellite, assuming certain combination of diffusive or specular reflections, using analytical expression, and then rescale to other attitudes. But as long as the mission design phase continues, then the estimation of the brightness needs to be done in the full 3D geometrical model, and then they have to produce a lookup table to sample different observation geometry in order to infer statistics for different operational modes. And in the process of creation of that lookup table, they will quantify the flares and glitch occurrence. And they will have to update as well the brightness estimations, either by measuring the VDRF material sample test, or when, for example, they have to go through the full qualification campaign, there we can use those tests to get more updated material properties regarding the brightness. For constellation, basically, it's just assess an aggregated effect of the satellite constellation, either considering the number of satellites simultaneously in the sky or frequency of passes for different latitudes. And last but not least, there is one specific requirement for quiet skies. Actually, this is not as detailed as the others, just because ITU radio regulations cover quite a lot, but includes as well that they have to be compliant with the ECSS standard, specifically these clauses. And basically that requirement with this saying is the maximum powered flux density values for different frequency bands to protect radio astrometry observation from spacecraft unwanted emissions. The verification is going to be done via review of design, basically to ensure that unwanted emissions of a spacecraft falling into the frequency bands of radio astrometry comply to the levels provided in this requirement of the ACSS. Then they have to guarantee and assess the interfaces and procedures on how they intend to inform radio telescopes whenever the spacecraft passes over them, and also as assess aggregated effect of satellite constellation. The current status, we are in the consolidation phase of the handbook. It is being coordinated by the ESA Space Debris Mitigation Working Group. Follow-up steps will be to iterate with industry to produce the final version. And finally, there is going to be included several showcases example in different typical mission profiles, so CubeSat, Boxwing type mission, and constellations, in order to make sure, to help actually to facilitate satellite manufacturers and operators to assess the compliance with the requirements. And that's all from my side, so thank you for your attention.
Thank you so much, Beatriz. That was really, really good. We will continue with Carolyn. Yes, is Carolyn? Caroline. Thank you. Thank you.
For me to switch slides. Oh, this is a lip. Hopefully this stays up here. If not, we'll see. We're living on the edge. Sorry, just have to wait for my slides. Oh no, they should be up on here. I sent them on Friday, right?
Yes. Carolyn.
Carolyn. followed instructions, so it should work.
Don't worry.
Okay, perfect. Thank you
There we
so
go,
much.
there we
Thank
go.
you. Okay, I might step away, but I'm hopefully will still be picked up by the mic because I'm very loud and American. So my name is Carolyn Crichton, and I'm the director of the Swiss Consortium for the SKA. We call ourselves Sketch in Switzerland, and I'm here to talk today about how EPFL coordinates research and community interests for Switzerland in the protection of dark and quiet skies. Is it not picking up? Okay, I'll be closer. Okay, so I'll stay close. Okay, yes. So the first thing is I'll talk about why is Switzerland interested in this issue. Then I'll talk about the Sustainable Space Hub at EPFL, and then finally the research that they're doing with this issue. So first of all, why is Switzerland specifically interested in dark and quiet skies? So I mentioned that I'm from Sketch. So Switzerland joined the SKA as a full member in 2022, and scientists have been involved in a lot of radio astronomy and optical astronomy projects. But in addition to that, several Swiss industries are involved in making these large constellations, so they would also be impacted by regulations. So it's really important that we hear both sides of the issue. So EPFL has been organizing meetings both with scientists and industry, and after each meeting, we give an opinion paper to our delegation for UN COPOS. To make sure that they're abreast of what the community feels. In addition to that, we are hosting the first Swiss Sustainability Research Days in Davos in January 2025. So next I'll introduce the Sustainable Space Hub. So the Sustainable Space Hub was recently developed at EPFL to ensure long-term space usability. So first, they want to measure to fill knowledge gaps. Second, they seek to understand, so analyze the risks and environmental implications. And last, they seek to act, so assess mission design and policy making. And lastly, I wanted to discuss some research that's being done with the Sustainable Space Hub. So they are working closely with the Space Sustainability Rating. So the Space Sustainability Rating is a tiered system to assess the sustainability of satellite missions. They focus on environmental impact, space traffic management, collision avoidance capabilities, and regulatory compliance. But there is currently an effort to add a module to assess dark and quiet skies. So this module has been in development, but it is currently being fine-tuned with the community to see if it can be added into this rating. I do want to say this rating is active, and several satellite companies have already been rated. So this is something that we're trying to plug in a new module for dark and quiet skies. Oh, and I want to say there's also a software being developed called ACT, which is to make sure that we don't do burden shifting, which means we don't recommend things that will affect other aspects of sustainability, like recommending toxic paint or something with a large CO2 footprint. There was a talk in the session earlier about we don't know what happens when these satellites burn up in the atmosphere. So we are studying that as well to make sure that we're not making recommendations that later on will actually cause more problems. And then, oh, this slide is a little messed up. Sorry about that. So we are also studying large optical surveys to find streaks across the astronomical data. And this is to help us figure out, what is currently going on, and then also help us predict how these future satellites will affect optical astronomy. And it should be noted that we are able to pick up objects smaller than objects that are currently registered. So this has been really important work that's going on at EPFL. And in addition to this, we will be joining this optical survey research with some radio astronomy research that's being done by Chris Finley at the University of Geneva, and he'll be speaking more about his research tomorrow, so please go check that out. So our research has been done in optical astronomy, but we are looking to combine both optical and radio astronomy. So thank you. As you can see, this work is being done by several different groups. So if you would like to collaborate on anything, please reach out to me and I will connect you to the groups involved. Let's work together to find solutions to protect dark and quiet skies.
I did my best. Thank you so much, Carolyn. That was quite good. We will continue now with the lightning presentations. So we have 3 lightning presentations. The same document at the beginning. The same slides at the beginning. So we have, the first one is John Barentine. Is Barentine or Valentine? Barentine, thank you.
Okay. It should not be my presentation for the CE part. Anyway, I'm John Barentine. I know a lot of you, but I don't know a lot of you. I'm with the Community Engagement Hub of CPS, and that should be my poster. Yeah, this is the lightning talks for the posters. It's not our CE Hub session yet. Well, they're trying to figure this out, and in the interest of keeping things moving, there's a lot of concern about the present situation with dark and quiet skies and with the impacts of large satellite constellations on astronomy. And there's a lot of worry about the future, but there hasn't been a lot of consideration of the past. And unless we make an effort to understand our past, we can't really know what we're in as far as the situation in the present, and we really cannot anticipate our future. And so my poster is about an episode from the recent historic past. And I'll say recent because it's within the past several decades, but it was at the dawn of the space age in which astronomers around the world were confronted with a threat from space. And they rose to meet that challenge in an era when there was no, as of yet, any international cooperation, which we have now through things like the Outer Space Treaty and the process that results from that. And to highly condense this story, and I encourage you to come talk to me on my poster, but basically in the early 1960s, the US military conducted a test of a system that was intended to replace the effect of radio propagation in the ionosphere should there be a nuclear detonation, perhaps by the Soviets at high altitude. And they did this by launching hundreds of millions of fine copper needles, little wires, into space in something that was called Project Westford. And they did that initially without any consultation with anybody because they were the US military. Astronomers were very alarmed by this, as you might imagine. They did not know what the effects would be on optical or infrared or radio astronomy. They protested this action. They elevated it to the point that in 1961 at the IAU General Assembly, the IAU came out with a very, very strongly worded statement in defense of astronomy, which I would invite you to compare with the current stance. We good? There we go. In fact, those are in the center there, that's the group of people at the IAU in 61, so you can see it's a much bigger event than nowadays than it was then. But the stance that the IAU took in part influenced the development of what became the Outer Space Treaty, and in particular, it's Article 9 that talks about the need for cooperation and consultation before countries engage in space activities that could have impacts on activities like astronomy. So if you'd love to know all the gory details about Project Westford and how amazingly it changed the course of international space law, please come see me at my poster. Thank you.
Thank you so much, John. I'm so sorry that we had this problem at the beginning. Now we will continue with Giorgio Siringo. Yes, thank you so much. You can use this one.
It's only one slide.
Yes. Yes.
Good afternoon. So I have a poster, and my contribution is only marginally related to policies in this session. But I want to mention that at the ALMA observatory, I don't know if you are familiar with this, ALMA is a radio telescope in northern Chile. And we started to we started an office for spectrum management. This is relatively new. And what we are trying to do is to also participate in the process for the policies, of course. And what I want to show, I mean, my poster, I think is number 6 down there. Please come to talk to me if you are interested. We have a plan practically to do to act in 3 ways. One is would be monitoring. So we want to know our enemy, right? We have to do monitoring to know what the problem is and how big the problem is. And then we want to do some prevention to avoid the problem eventually. And the last step, we do coordination with different levels. We try to coordinate within Chile, for example, with the National Authority for Radio Telecommunications, and they are pretty supportive at the moment. This is quite important, for example, for the preparation work of the preparation work for the WRC 27. So where we are trying to be very active there and try to support the agenda item 116, which is protecting some from some frequencies that would be affecting ALMA band 1, and for the agenda item 118, which is related to ALMA band 2. What I want to say finally is that at the moment ALMA doesn't have any problem, any impact from the satellite constellations, but there are already new licenses from different companies, and they already have the license to use ALMA frequencies. So it is coming. We know that this is coming. So and we have to act now. So this is the meaning of my poster. So thank you.
That was really good. Thank you. Now we go to the last presentation. That is Pedro. Can you hear me, Pedro? Yes. Is he online? Yeah, he must be online.
Okay.
There you go. Thank you, Pedro.
Well, this is a very quick presentation, of course, and the main 2 points are here that in general, we are in the last, I think, 3 or 4 conferences talking about international cooperation, even into United Nations, in order to work on these environmental new issues regarding with satellites constellations. But I'm almost sure that here in this conference, for example, the Secretariat of the Ozone Layer Environmental Agenda is not part of the conference. We even have an international tool, which is the environmental impact assessment, available for many years, and this is a possibility to be now working with the satellites companies under voluntary basis in order to promote cooperation between the companies and also the international bodies. And we have to start soon because of the proliferation of satellites constellation. So I think that the next conference, it's very important to have all this, the Vienna Convention, Secretariat for the Ozone Layer, people in charge of the environment, and discuss with them very quickly. That's all. Thank you.
Thank you so much, Pedro. Thank you. So now we will, there you go, thank you. So now we will have time for questions, conversations, discussions. We have 30 minutes, if I'm not wrong. So we have 4 minutes, yeah, okay. So we have 4 minutes for discussions. 30 minutes was a lot, but yes, we have 4 minutes for discussions. I know that already there were a lot of comments going online, But first of all, I want to thank to all presenters, because they were very, very good presentations. Fortunately, we will need more time to talk about that. I want to start with someone here. Federico?
Thanks. Yeah. This is a quick question for Beatriz. It's great that ESA is looking into all these new constraints for missions. I would like her to make a comment, if she can, on how is that perceived from the program side of ESA, that new requirements are being imposed into missions. Are you the odd one out, or how is that being perceived in ESA? How do you approach that?
I'm not sure if I'm getting your question. So it's like if we received internally inside ESA, actually it's just the opposite. It was the DG promoting the zero debris approach. And among those requirements of the zero debris approach were the dark and quiet sky. So it's actually quite a cooperative endeavor of the entire agency.
Okay,
So
yeah, exactly. That was the question. Thanks.
Okay. Yes. So yeah, it's more than welcome. And also because I didn't have time on the 5 minutes, but of course the handbook includes as well potential mitigation measures in order if we assess that the mission along the design is not compliant with the requirements. And that is promoting several new activities and developments, specifically on material properties estimations and so on. And also investigation on design for demise. And so there is kind of several technical aspects that are enabling new activities in order to be compliant with the zero debris approach. So yeah, it's an effort at the agency level, and everybody welcome it.
Thank you. Any other question? We don't have any questions online, as far as I know. Please, Richard.
Well, another question for ESA. No satellite maker has been able to achieve 7th magnitude so far, even for their microsats. Is it actually a requirement, or are you approaching that as best efforts when you actually try to impose it?
It's a very good and fair question, and it's in a very so basically, of course, it's not going to fulfill that in every single of the position of the orbit, and yeah, we agree with you. It's on a best effort basis. So it's in order to identify that as an average, it's not violating that magnitude, and if not, then how there we are going to assess the different mitigation actions on the satellite. So if every time that is passing to very sensitive sensors like the Vera Rubin, then at that moment perhaps ask for a specific maneuver in order to avoid the glints. That's kind of the balance and trade-offs that we need to see. And of course, when we iterate with the industry there, we will receive this kind of comments. And on top of that, while we are developing the showcases with a specific typical missions type, there we will realize about the limitation of the requirement itself. But yeah, it's a fair question and comment.
Thank you. We just have one more question left. Is it possible?
To me? No. Yes, sure.
I don't know for any, but do we have?
Okay, sorry.
Okay. Unfortunately, we cannot do that because we already finished. But if you can just send that question on the Slack channel, that would be fantastic. Thank you so much. It was really good. I hope that you enjoyed, and we'll be around so we can have more conversations about this. Thank you.
Marietta, are you there?
Yes.
There were 2 online questions. One is short, I think.
Yeah, but we already finished. But
time. Okay.
We cannot.
Thank you. Sorry.
Yeah. Yes, but you can send it to me, and we can just do it on the Slack channel. But thank you.
I'm
Thanks.
copying and pasting them onto the Slack channel at the moment, so they'll be there.
Okay, we're going to continue on here. Maybe we can not have the music going because this isn't technically a break. Okay, so we still have another 30 minutes left in this session before the poster break. So let's get started again here. Okay, so this is now the CE Hub session. We're kind of divided in half. For the next 30 minutes, we have talks. We have 3 talks, and then we will have our 30-minute poster break. And then we will come back, and the first 30 minutes of the next section will be the rest of CE Hub, and we will have a full half hour for discussion, and then we will hand it over to the INT Hub after that. So just getting started here, I'm Jessica Heim, and along with John Barentine, I co-lead the Community Engagement Hub of IAU CPS. And unlike all the other hubs that you have been hearing from, we are tasked with mostly going to how do we engage with everybody else on the planet, because it's not only professional astronomers who look at the night sky, but there are other people too. And so we're tasked with engaging with other communities that look at the night sky and are affected by the constellations as well. And then we're also working on developing educational materials that are of use to both the professional and amateur and everyone else looking at the night sky. So let's get started here. Our first talk is actually John Barentine, and then I will come back. John will first introduce you to the history of CPS CE Hub, and then I will come on and discuss another subtopic. So here's John. And we need to make sure we have John's slide up. This is my presentation. We want John's. And then we'll have this after John.
There we go. All right. Great. Thank you, Jessica. Thanks, everyone. I'm going to basically tee up the rest of this session and this conversation about the Community Engagement Hub again by giving you some historical context, and I'm also going to tell you where that has led us based on the work that was done, particularly in the SATCon series of conferences and the Dark and Quiet Skies conferences. I'm going to tell you a bit about who we believe our constituencies to be, who are the interested parties in this story besides professional astronomers and the space industry. So we are outward looking to the rest of the world beyond this little ecosystem that we normally think about when we talk about effects of satellites on astronomy. And then I'll tell you a little bit about our initial outputs and our future plans that are coming up. So the stage has been set from the beginning of the sessions today for the context here, which is what I would argue is a very new use of outer space that began in 2019 when we suddenly and dramatically began increasing the number of objects orbiting the Earth. And since that time, you heard Andy say earlier that we've crossed the threshold of 10,000 objects in low Earth orbit, I believe he said. And there have been more objects launched into space since this time than were launched into space during the entire history of the space age from 1957 forward. So it's just a radical change in the way that space is being used. Trying to get to my next slide. Okay. Okay, can you give me my next slide, please? And of course, I think many people have seen examples like the picture on the right there, thank you, of the bunches of Starlinks traveling together that really got the attention of the world at the time that the first launches were taking place. Too far. Maybe I can go back. Okay, I've got control of it. So the astronomy community reacted to that pretty quickly. There were a number of stories written in major media outlets around the world talking about the concerns that astronomers are raising once they begin to see streaks like this in their images. That was followed pretty closely by statements from all of the organizations that you see down there at the bottom that represent some aspect of astronomy or concern for the night sky, expressing very similar worries about what this could mean for future access to the night sky, future access to astronomical research from the ground, et cetera. But more importantly, not only did the astronomy community react, but it also got organized. And it organized itself in this group of conferences that I mentioned earlier that were called SatCon and Dark and Quiet Skies. The SatCon conferences were organized mainly in the US through the US National Science Foundation. Dark and Quiet Skies was a bit more international. IAU had something to do with that. Noir Lab was one of the sponsors. And most importantly, it fell within the UN process through the United Nations Office for Outer Space Affairs. And there were a number of outcomes of those conferences, not only in terms of trying to understand the significance of the threat to astronomy and make some predictions about what that could be in the future, but then also talk about where do we go with this? How will we confront this problem and deal with it, hopefully in an effective way, so that we can find a coexistence between our use of outer space and that of the commercial space industry, who in the international legal framework have the same right to access. So we're talking about a future in which there is some form of coexistence. There were a number of findings that came out of this process, and I just want you to pay attention to some of the words that I've highlighted here rather than reading everything. Words like community, words like direct and ongoing engagement, a duty to consult, being mindful of relevant treaties and laws pertaining to the rights of indigenous people to continue to access the night sky, many of whom view it as an object of cultural and religious significance. And these groups are often those that have the least in the way of resources to deal with them. So this new use of outer space is putting a burden on groups that have not really been burdened like this before. How will we find a way, again, to coexist as those numbers get bigger and bigger and bigger? There was, in particular, in the SatCon 2 conference, a community engagement working group, which I think was very forward-thinking at the time. Again, let's talk about this broader community that's outside of professional astronomers and the commercial space industry, knowing that that's a large and diverse and geographically distributed group of people. And these are their literal words. Things like space is a global commons. All people are impacted by changes to the night sky. This is colonization expanded to a cosmic scale, and that the sky should be part of the environment, and that ecosystems are dependent on this. This is bigger than astronomy. This is bigger than telecommunications. We're now talking about the entire planet. It is from these common themes and these principal findings that our hub takes its inspiration. There were a number of specific recommendations that came out of the SatCon 2 Community Engagement Working Group. Learn from the past. Engage with industry. Don't stand by and simply be an obstacle. The notion of science versus internet is a false choice. It's not one or the other. It is not a simple binary. But most importantly, continue active engagement and conversation. That's the way forward. And that's what we have adopted as the ethos of our hub. I said we had a number of constituencies that represented interested parties in some way, again, beyond just the limited audiences of commercial space and professional astronomy. Professional astronomers are one of our constituencies because, as we find, there are a lot of people in this community that are really not very aware of what's going on. I wish this room were about 5 times bigger than it is and that we're full of people right now, because this affects everyone in the astronomical community. But we also count people like amateur astronomers, people who engage in astrotourism operations, which is an increasingly large sector of the economy in certain parts of the world. It's rural economic development. It's part of our future. But this is also people like those who just casually like to look at the sky every now and then, and also the other 8 billion people in the world. These are all potentially our audiences that we are trying to reach through the Community Engagement Hub. Some of the things that we have done already is this project that we call SatCons 101 that you'll see more of. Jessica will talk more about it, so I won't go into too much depth. But one of the things that we learned very early on in our work is that we need to do as much education as engagement. And I say that because many of the people in our constituencies are not very aware of this issue, or maybe they don't consider it to be a problem because they haven't seen it for themselves yet. So we have to do outreach and education as much as we have to do engagement. And some of that educational work has to come before we do the engagement part, before people can come to informed and reasoned opinions that we can then talk about and carry that information back to the space community, the community of professional astronomers. So one thing we started here with is a curriculum of material to inform people about the issues, that they can learn things in a way that's fact-based, that's just passionate, that just gives them some basic information so they can make up their own minds about this. And then some of the things that we're going to do in the future is we're going to work more on external communications. We're right now developing a strategic communications plan that will be overlapping with all of CPS so that we're all on message as much as possible. We want to make contact with new constituencies, new groups of people that we've not talked to before. We want to cooperate both inside the IAU, its offices, divisions, et cetera, and outside with other organizations that are interested in these issues. And fundamentally, before we can talk about engagement, we have to build trust in our constituencies. And to do that, we have to build relationships, and this is simply going to take time. So what I will leave you with here before we transition to the next speaker is we've captured a lot of this, our history to date, the outcomes of the conferences, what we believe our mandate is, and how we will pursue it in what we call our foundational report. It's available on the archive. You can scan that QR code, and please feel free to talk to me or Jessica more about it afterward. So thank you for your attention, and on to Jessica.
So let's see if my PowerPoint comes up. Looks like it's in process. See if we can get on the first slide. Okay. So how we got here, John told the story of how CE Hub emerged. And so we started off with the focus more so on engagement, and then we found, as John mentioned, that a lot of people felt that they were not sufficiently well informed and educated on the topic to develop an opinion. So then we thought, okay, well, we need to develop some educational materials as well. So that is how we got into that. So the purpose of the educational materials is not to tell people what to think, but basically we're trying to provide unbiased, fact-based information about the constellations, how the satellite works, what they're intended to accomplish, what the impacts are on professional astronomy as known to date, and any other research that we have information on that talks about the effects of the satellites, so people can become basically informed on the topic. Oh, and then one other thing as well, and in doing this, we're helping to raise awareness of the existence of CPS and the work that it is doing. So I thought I would mention a little bit some of the challenges we have experienced with this so far. So we have a low budget, and the entire world, as John discussed, is our constituency. So that is very challenging to accomplish. We created these SatCon 101 videos that I'll show on the next slide. Not the videos, but about them. But we haven't had like tons of viewership. There's like these short 10-minute videos about different topics, but we are thinking about, well, how do we make more people aware of this resource? And then one common question that people come to us a lot with is, once we inform them about the topic, well, they are like, well, what do we do? We want to advocate for this. Let's go, do something really action-based. And the way CPS is set up, we're not like a nonprofit that can, some people are like, oh, just go sue the satellite operators. And I'm like, well, that's not the structure that CPS is working with. So then when people say, well, we want to do something, what are the things we can tell them to do? So we tell them they can contact their national delegates to COPUOS or their national elected officials, or reach out to their IAU National Committee. And the QR code here is for the CPS position statement. that has recently come out, and so that is also something that people can support if they wish to, and also share with their colleagues and other people they know to become more educated on the topic. And this is the QR code for our SatCons 101 curriculum. We encourage you to check it out. It is a series of just 10-minute videos on all sorts of little subtopics of this, so you can take little bits of time and become very well informed on it. And looking forward, what do we want to do next? Because this was our first big hurdle, was doing the SatCons 101 curriculum. We've been talking about doing a planetarium show, and this would be really good because it would educate and engage large numbers of people on this topic. Planetariums already attract large numbers of people, the general public, who are interested in science and space issues, so that would be a really good place to reach people who would be interested. And one thing that would be really interesting to do as part of that is to show simulations like Siegfried was talking about earlier for his VR headset. If we could do simulations in a planetarium that would illustrate what the sky looks like now, what it would look like with different numbers of satellites, and then also show what those satellites would look like with and without different kinds of mitigation, so people can get a visual sense of what that actually looks like. And so different things you can do to get involved. You can share our curriculum. You can inform your colleagues and everyone you know about these issues. You can become a member of CPS and join CE Hub. We're definitely interested in hearing from you. And in particular, if you would like to be involved with the planetarium project, or you have any other ideas, suggestions, people who have background in this that can work together effectively to help us with this, that would be wonderful. So reach out to us via email or join our hub. And I deliberately didn't want to talk too long here because I was more interested in having a little bit of Q&A for a couple minutes here. So questions I have for everyone here: what kind of resources would you and people you work with find most helpful, and what format would they be most useful in? And what specific things do you want to know more about in regards to satellite constellations? And then what suggestions do you have for us on ways that we can interest more people in becoming involved with this and caring about it in different ways? So we have a few minutes we can discuss before we go to our next speaker. Does anybody have any thoughts on any of these things? Because this is what John and I are wrestling with now, and we'd love to have feedback.
Thank you. I missed the part about the software for planetariums. I think I was distracted. Can you, are there, I mean, you have relationships with specific planetariums yet, or that's coming, or?
We're in the very early stages of it. We have a couple people, a handful of planetariums who said, oh yeah, that sounds like a cool idea. And that's about where we're at. We're working on trying to develop a more strategic plan, so then we could put in like a funding request of what's our budget proposal, but we're very early on in it, and we need more people who have experience doing planetarium shows.
Because those kind of simulations are very powerful, very evocative.
Yes, if you haven't seen Siegfried's 380,000 satellites in the sky on a VR headset, make sure you see that because it's stunning. Yeah, it's at our booth.
Great, thanks so much, John and Jessica. At the risk of stating what's so obvious, there's really limitless opportunities here for engaging the community, and the resources to scope ratio is the challenge. I mean, the list of stakeholders you presented are so broad that I think to increase impact, you have to zero in on one of them. And even if one of them is the 8 billion people in the general public is zooming in on a constituency. Like, is general public your top, are the youth who are movers and shakers your top focus? Well, then thinking creatively about how to engage with different types of social media in a way that can really proliferate it makes sense to be a focus to engage with Gen Z. When I see these materials are beautiful, and to me they still engage, they're focused on professional astronomers, like SatCons. A random person doesn't know what a SatCon is. They're not going to be drawn to something with that name. And so this is not a criticism of what you've done, but just an encouragement to really think about where do you want your biggest impact to be, and invest in there and pull together folks with experience reaching those specific audiences. I'd love to talk more if you were interested. This is great, thank you.
I'll echo that. Great, great, great. And I actually have my students my undergraduate students in college watch your SatCon 101 videos, and they get a lot out of it, and they get angry, and they want to know what to do. And I have my own ideas, but I think you put your finger on it, Jessica, when you said, well, the CPS doesn't really, that a lot of people come to the CPS and say, what can I do? And you can't really do that. But now's our chance for us to articulate what comes next. The AAS has produced, as you know, we all in this room who are AAS members likely worked on the leave behind papers that are intended for representatives, elected officials. They're not really intended for the average layperson as instructions for how to engage. Maybe that's one of our next steps, and maybe that follows on Beth's good suggestion as well.
Hi, yeah, it's Richard Green. I'm puzzled by how we change attitudes because, you know, if you drive over the crest of the hill and you see a load of sparkling lights from a town down below, 95% of people will say, wow, look at that view. And only we say, look at all that wasted light and pollution of the sky. And so similarly, you know, if SpaceX is launching a tranche every other week, there's just this wow factor where you say, look at that streaking light in the sky, isn't that amazing? As opposed to look what they're doing to our pristine sky. So how do we change attitudes and, you know, and have everybody want to be a preservationist rather than getting wowed by sparkle?
I think we need to move on to our online speaker now, but come back after the break and we will have more discussion. So Samantha Lawler, she is next, and I think she's going to share her own slides. And Samantha, are you on? Can you hear me?
Yes, I can hear you. Can you hear me? Oops. Hang on. Let's see. Oh no. Let's see.
Okay, we can hear you.
You can hear me now? Okay.
Yes, great.
Let me reshare. Sorry. Okay. You can see my slides? Yes?
Yes, we see them and we see you.
Okay, great. Good morning, everyone from Canadian Treaty 4 territory. I am here as an astronomer and a satellite regulation advocate. And so my goal is to make you all really angry and then tell you a bunch of things that you can do. So how many of you in this room right now have said these words? No, it's not a UFO, it's Starlink. I'm guessing probably a lot of you. So this is really common, right? People see Starlink satellites, particularly right after they launch. There are thousands of them, right? This is where we are right now. There are more than 6,000 Starlink satellites in low Earth orbit. They represent the vast majority of all satellites, and that's one mega constellation, right? There are many other companies that are lined up to do the same thing that Starlink has already done to the sky. And just how quickly this has happened, right? Just a reminder, right? 5 years ago, there were 0 Starlink satellites in orbit, and there were fewer than 2,000 total satellites. So this has happened so fast. So when most of you know this, but when Starlink satellites first launch, they are very close together and they are in a much lower orbit. So they are super bright and people see them, even people in cities, people who don't usually look up at the sky, they notice them. To the point that the New York Times had this hilarious article a while ago about UFO reports have surged during the pandemic. Everybody's losing their minds, and they did not once mention Starlink, but that's when Starlink started launching, right? 2019. So that's people are noticing. all over the world, right? Like I just quickly grabbed a few headlines, right? Here's one from India, here's one from the US, here's another one from the US and another, here's one from Canada, here's one, right? So this is there are satellites being seen all over the world. People are reporting in that they see UFOs. I don't know how many of you have seen Starlink trains before when they're super low altitude. They're incredibly bright, right? Like I modeled this and I still thought it was a UFO when I first saw it, right? And every single one of these articles about UFOs has some line about SpaceX did not respond to a request for comment, right? SpaceX never responds to requests for comment. So who is teaching people what these are? Astronomers, right? We are the ones getting the emails and the phone calls, and we are doing SpaceX's public education work for them on this issue. There are these bright reentries. I didn't share my sound, but in this video, it's like a mom and her kid who are talking to each other like, oh my gosh, is this okay? Are we okay? Right? Like this is terrifying to see. And this is becoming much more common. Who's teaching people what these very bright reentries are? Astronomers. And what about space junk? What do you do when you find space junk? Apparently, you call astronomers, right? So these are pieces of space junk from SpaceX that fell on a farm an hour away from where I live. These are pictures of space junk that fell on someone's house in Florida. They were not able to get in touch with NASA, so they talked to Jonathan McDowell, the astronomer, right? So astronomers, we are doing all of the education work. At the same time, we are watching our research data get more and more destroyed by satellites, right? We're being asked to quantify how much our research is getting destroyed. While while we're trying to mitigate the effects of this destruction, right? So this is my data. This is my data from CFHT, full of satellite streaks. This is a Kuiper Belt object that we missed in our automated pipeline because a satellite flew right in front of it, right? We are running models to see how bad is the night sky going to be, right? This is South Africa. This is the sky from South Africa with 65,000 satellites that have similar properties to Starlink satellites, right? So this is what your night sky will look like. And again, this is work that that perhaps satellite companies should be doing. They should be teaching people how they're changing the sky, not astronomers necessarily. So this is my wish list for what satellite companies should be doing as they're launching their satellites, right? They need to consult affected groups, right? Especially indigenous groups. The right to access cultural heritage, such as the night sky, is codified in the UN Declaration of the Rights of Indigenous People. That consultation is not happening right now. Satellite companies should be sharing information on their satellite shapes and sizes and compositions and orbits. They share the orbits, but not much else, right? If you want to find out the shape of a Starlink satellite, they ask you to sign a non-disclosure agreement. This is not helpful. They should be doing the education. They should be teaching people how the sky is changing. They should be teaching people that these Starlink satellites are not UFOs. They should be answering journalist questions. It shouldn't fall on astronomers to be answering every single question from journalists because SpaceX refuses to ever answer them. They should be compensating taxpayer-funded facilities that are now less effective because they're full of satellite streaks, right? Our data that is, our research facilities that are taking data funded by taxpayers are less effective now because of the actions of private companies. Satellite companies should be running cost-benefit analyses to including environmental costs, right? How much is the ozone layer worth, right? That analysis is not happening right now. And most importantly, satellite companies should be thinking about how to launch fewer satellites. And there's many ways to do this. Can they cooperate? Can they share infrastructure? There is a limit to how much we can have in orbit safely and without consequence. And I think we're beyond that right now. So how do we work with what is already there? How, it used to be that cell companies each company had their own cell tower infrastructure. And then they started sharing that infrastructure, right? So can satellite companies do the same thing? Can we have multi-purpose satellites instead of single-purpose tens of thousands of single mega constellation satellites, and making them last longer? So this is my wish list. Okay, so hopefully you're very angry now. Here's a list of what I think you all can do, and many of you know all this already. But this is my recommendations to astronomers, right? So consumer pressure is the easiest tool that we have access to, right? If you have alternatives, don't use satellite internet, especially not Starlink, right? Especially not services from low Earth orbit. There are some from geosynchronous orbit that are better regulated and are not terrible. Tell people what's happening, right? Show people these great videos that John and Jessica have created. Tell people that this is happening. Most people have no idea. Talk to your local and state and federal governments about getting better internet access to people in remote and rural areas, right? That's what is driving all of this. So if people in rural and remote areas have better internet access, they don't need Starlink, right? Use your skills to show people the sky. This is so important, and many of you do this already. Keep doing it. It's so important. And get out and enjoy it yourself, because it's changing now. And then lastly, the FAA has a comment submission open right now on additional Starship launches from Boca Chica, Texas. There are instructions on KesslerRebellion.com for how to submit those. You don't have to live in the US to do that. So yeah, just a reminder, we astronomers are the canaries in the coal mine for this environmental disaster that's happening in orbit. So we need to tell people. So thank you for listening.
So thanks so much, Samantha. We're over time here, so we're going to stop. We'll have our poster break, coffee break, and then Samantha will be back here for our discussion so we can continue to discuss when we return. And John and I both have posters, so you can come and check them out, and we will see you later. Bye.
I would love to. He's an amazing professor to attract amazing students. Okay, see you later.
Okay, I think we're gonna get started here. Sorry, I'm a little out of breath. So the next half hour will be Community Engagement Hub. This is just free-form discussion, Q&A. So any questions you have for John or I or Samantha Lawler, we're all available for questions and discussions. And then at the top of the hour, we'll switch it over to the Industry Hub. So yeah, we can continue where we left off before. Any questions for any of us? Anything? Yeah, let's do that. Yeah, can you put the tech people, can you put Samantha Lawler up on the screen so then we can hear and see her? And we don't need any PowerPoints up for this part. This will be the part at the top of the hour.
And I'm here, so hi.
Okay, there you are. Okay, Ruskin, question, comment? And then, yes, microphone.
Thanks, Jessica. You mentioned in your remarks the importance of kind of developing a strategic communication strategy. And I kind of wanted to start from the top there, because I think this field has a couple challenges when you try to describe it to the public. First is, if you mention dark and quiet skies to most people, they automatically think about soundscapes, and they're all about that. And I even was working with one journalist who works in the astronomy space, and I asked him to write an article about mega constellations. He said, "Oh, I love it when a series of constellations are aligned in the sky and you tell a larger story." So I think there's some. I'm curious what thoughts you have about creating a language and a vernacular around this that will bridge it towards the 8 billion people you're trying to reach who don't understand what a quiet sky is or a mega constellation.
Yeah, the quiet skies is definitely something that has come up a lot. Like, we've been keeping with that terminology because it's become fairly established, and is dark and quiet skies is a phrase that is starting to be understood within the astronomical community. But yeah, outside of people who know what radio astronomy is, they don't know what that means. We tend not to discuss it as much. We just talk more about the optical and other aspects of it and say, oh, well, it impacts radio astronomy as well. But yeah, I don't know, John, do you have any other further comments on that? We just haven't really focused on quiet in our discussions as much, other than here's how it impacts radio astronomy.
No, there's a huge barrier to engaging on that. Ruskin, you asked a question that's very similar to one that Robert Massey asked in the Zoom, is how do you convince people to care about something that they don't even know exists, right? So that goes back to the education piece, and we have a lot of that to do before we can talk about convincing people that it's worth investing their concern in. Totally honest. Yeah.
Picking up on that great question, the points that were made, I'll say something a little bit heretical. We in this room and everyone who's online are by and large experts in technical things, in science, in policy. We are not experts on influencing the general public, but you know what? There's a whole lot of people who are. And in this Don't Look Now, or Don't Look Up, what's the movie on Netflix, the Don't Look Up moment, bringing in the experts from all different fields to move quickly in influencing the public perception of what's going on, I think is an incredibly important piece. And yeah, it costs money to bring in experts. And I know that's a barrier in making contracts tomorrow, but I would be very interested in seeing outside the box approaches to, this is what private philanthropy was tailor-made for. And I know that it's a challenge, like this can't be done necessarily inside the CPS IAU box, because there's a lot of different, political and other sorts of boundary conditions. But as I think was very nicely described in the entire last session, this is bigger than that. And so I'd love to hear this discussion and other discussions to let it get bigger than that.
Just to respond to that briefly, yes, like as far as communications, that is definitely something that we have discussed a lot, that like we want to interact more with people who having more expertise on communications, that type of thing. That's something we're working on with our strategic communications plan. And then the other point you mentioned about the broader constituencies, that is an issue, and that's something that is continually discussed within CPS and all the organizations I'm involved with, is just like, to what extent do we as astronomers just talk about the night sky aspect, and to what part do we speak about and engage with the larger context? And because like there's the whole ecological context and things like that, and like what is a most effective mechanism to have dialogue with people from outside of astronomy? I think that's an ongoing question that we need to continue to work with.
I'm Colin Carlisle from Sweden. So I went for the coffee break, but of course it's the first conference I've been to where there's no coffee break. So I used the opportunity to go into the marketplace down on the ground floor. And the second stall that I went to, the woman who was there with her handicraft, she said to me, "What are you guys doing here?" I said, "Oh, you don't know what it is that we're doing?" "No," she said, "I don't know what's happening inside those halls." She said, "We are not allowed in there. So what are you doing?" So I spent about 15 minutes talking to her. She was an intelligent person. She wanted to know. I talked about the solar system. I talked about the Earth. I talked about satellites. I talked about exoplanets and whether there is intelligent life or indeed any life around other planets. We talked about galaxies. And I said, but the organizers of this huge conference did not think it was sensible that maybe the 30 exhibitors who are downstairs now and will talk to anyone, they're sitting there rather lonely. The organizers of this conference did not even think that they should spend 15 minutes with those people and tell them what it is that we are doing here. So whilst we are talking now in our bubble about how we can contact people around the world, cannot even contact the people who are beneath our feet, 2 floors down. And therefore we rather lose focus in a situation like that, when even the people around us we don't talk to. Do we talk to the Uber drivers? Do we talk to the people at the hotels? We don't. But we have these rather ethereal views about how important it is to spend lots and lots of time and lots of money talking to some people that we don't have contact with. We've got contact with these people downstairs. Therefore, I would urge you to go down and talk to the people. They want to know what the hell we're doing. Anyway, thanks for listening.
Just a brief follow-up on that point. Yeah, I appreciate you sharing that perspective. And yeah, I think that's helpful feedback to keep in mind. I know, like, for myself personally, wherever I go and I talk to people, I always can't help talking about this stuff. And like people I talk to, I find they're super interested in this. Like I've done different public talks in local libraries and things like that. And they're always just very interested. And they're like, oh, I never knew this. Oh my gosh. You talk about the satellites and they're just like, oh, why isn't this being stopped? Who's in charge of, making sure there's not too many? I'm like, well, it's a little more complicated than that. And they're like, okay, well, what do we do about it? And then it's challenging to not have a very clear thing to say, okay, well, here are 5 things you can go home and do, because the thing is, like with ground-based light pollution, you can say, okay, well, this is what you can do in your community. You can do a local ordinance. You can improve the lighting in your backyard. But then when we talk about satellites, they're like, oh, well, we need to talk about international law. And how do people connect with that? Like when I mentioned the concept of space lawyers, most people I talk to, space lawyer, what is that? So yeah, good point.
I think one of the things we have to think through quite carefully is what alternative are we offering to what SpaceX brings? I mean, years ago, I was in a conference where it was expressed that look, this thing will never happen because it's obviously cheaper to lay fiber everywhere. But the world's gone in a different direction. When, as the MD of Soraya some years ago, we bought 135,000 hectares of farmland just to keep people away from a radio telescope. I mean, originally we had the idea that we were going to have people and sheep grazing among the antennas, but it wasn't practical. The farmers were kind of a law unto themselves and wouldn't switch their phones off and whatever. But yeah, I mean, and we did provide an alternative communication network, but they wanted nice, shiny phones. They didn't want some clunky handset that they would, you know, and they would anyway have to have a smart handset to take to town to use there. So yeah, we provided an alternative, but it wasn't completely acceptable. And I just would like to know whether there's any thinking as to what comes next, because you can't just jump up and down and say, you guys in the jungle can't have this stuff.
I could. Oh,
yeah, go ahead, Sam.
Yeah, I could quickly add that that is something that I do tell people, right? If you don't like all these satellites in your sky, go talk to your local government representatives about getting better rural internet to people, right? And making sure that the government doesn't say, oh, we have Starlink, we don't need to keep doing laying fiber for rural broadband. No, you really do need to keep doing it. So yes, I agree. There does have to be alternatives, right? There is a reason that people are very excited to get Starlink internet because there's a huge population of people who don't have good internet access right now.
Yeah, I think the argument, this is Siegfried again, the argument is really not that we should not have access or have people have access to these things. They just need to be regulated, right? Nobody says like you can't have nuclear power plants, but you can't just dump radioactive waste everywhere, right? That's not possible. And so regulation, I think, is the key. And if people don't like alternatives, then you should enable, you know, whatever they want, right? But it has to be, you know, done in a way that is not harmful to the environment and to anybody else, really.
Yeah, I think that was a good point that was made early on in the last session that, yeah, we really have to focus on the environmental aspects here. What's been interesting with being involved with this space junk fall right near my house is that people care a lot more about that than any other aspect, right? Even though, you know, any one individual's odds of getting hit by space junk are 0, right? Like you're not going to get hit by space junk, but for some reason, people really latch on to that particular aspect. And, you know, Starlink, for example, is going to deorbit 23 satellites per day on average, right? So this is, you know, this is something to talk about. So talking about all of those environmental issues that go along with tens of thousands or hundreds of thousands of satellites. Keep doing that. That's important.
This is James Lowenthal again. Sam, you mentioned there are tons of people who don't have fast internet, and if we quantify, well, of course that has been quantified, including by people working probably in this room. What we have not been able to do it with the benefit of is a clarity on the business model of SpaceX or any other company. And I guess my understanding, correct me if I'm wrong, is that really the market, the commercial market for SpaceX anyway, is not the remote regions. It's mainstream, mainland Canada, America, to a lesser degree Mexico, and then other places in the world. But that's really where what their cash cow is, and that they dangle the promise of fast broadband to remote territories as I think a way of whitewashing the business. Without revealing what their actual business model is. So I guess my question for this group is, to what degree is it important that we understand better their business model in order to shift the narrative? Because right now they're controlling the narrative pretty significantly.
Well, it's Richard, and I am occasionally the skunk at the garden party and going to aerospace meetings, and they're astonishingly frank, at least at some level, because they don't have PowerPoint presentations. They sit around in panels and talk. And on one of those, they asked that question, you know, what is your revenue distribution? And SpaceX doesn't go to those, of course, but the other companies actually do, and they were all quite honest about their models, or I'm sorry, they said words about their models, and they, in almost every case, about half their revenue was intended to come from the customer with a capital C, which meaning defense applications, and about another quarter to a third from higher bandwidth for video and consumer. And then the rest was sort of backhaul for, you know, backing up cell coverage and things like that. So that was a pretty common pattern. And that was a couple of years ago when last I heard that. And the question is, if countries are now wanting to fully control their own military constellations, is that business model still valid? Because you know SpaceX cleaved off a fair fraction of their Starlink constellation for dedicated military use. So they have the same model, but they distributed it by satellite rather than by volume.
Yeah, and a lot of this conversation about the internet, it's actually financial services might be a bigger driver here for some of the satellite providers. I don't know if I haven't been here for the whole meeting, but I don't know if that's been discussed. But the latency that a lot of you know about, closer you are to the Earth, the quicker the signal. So shouldn't that be discussed as well?
I kind of missed that. I was reading the online chat and I couldn't multitask here, sorry.
Yeah, sure. Okay, so I'm not an expert. I'm a photographer and science communicator doing some work for SKA here, but I've got a project called Our Fragile Space. We talk about all the benefits of space, how space is becoming congested, and what are we doing about the problem. But in the conversation about constellations, maybe a bigger financial driver is all the financial services for financial markets, trading, stock markets, and so on. So the closer they are to the Earth, the quicker the signal. So less latency, I guess is the term, much quicker than optical cables in the sea. So that may be a bigger financial driver for those services than the internet, or at least as important.
So is that more of a comment or a question?
Well, and I think the whole question of latency is quite interesting because there's a big move now to go to direct to cell from satellite. And I thought that would drive them to very low orbits to keep the latency down, but in fact, they're going to higher orbits, which makes their satellites visible through more of the night. So which way these things go is a little less clear. And so understanding the real market drivers would really be helpful.
Yeah, I mean, for me, everything in moderation. So that's part of the solution, in my humble opinion. But of course, that dynamic exists. The different altitudes, different unintended consequences. Thanks.
Might not be the most popular comment I do here, but I believe that I don't know if we should delve so much into what the market of these companies really is. I don't think that's our role here. And it will be very difficult for astronomers to understand what the market strategy of commercial companies is. Should we really be looking into that? I understand that it's very interesting, and it's a very interesting point to maybe have some discussions of how really profitable your company is. But I think it's difficult from our point of view because we are astronomers. I'm not, but I feel part of the group, right? Let's say. So just challenging that a little bit. And from my perspective, I think that what we should focus on is some of the things that were said before of finding our target audience, finding how we can make a change on that audience that can make the most of the impact, and putting our grain in this much larger discussion that is space sustainability. And in that discussion, there is a lot of discussions on these other things that were mentioned, right? What's the viability of all these constellations? And probably some people from industry after this session are going to discuss a little bit about that, maybe. But in the same way, I think if we get people from industry saying, well, there are some science cases in astronomy that maybe are not so used. Well, yeah, maybe we can say a little bit more about that. So it's just a comment there.
Yeah. And can I add, I think it's so important to keep in mind the huge power imbalance here, right? The satellite companies are making all the decisions. They're just doing stuff, right? And we astronomers are left here sort of begging for them to listen to us, right? So it's a really huge power imbalance that we're working against. So just, keep that in mind with all of these discussions.
So just a comment from Ruskin, just on the power imbalance. I mean, there's another part of the power imbalance, which is people trust scientists and they trust the professional communities in maybe the way they'll never trust some of these businesses, even though the businesses are delivering services that they're incredibly valuable to individuals. My other observation is that there's a couple instances where communities have come together to solve things. So one that we all talk about a lot is the ozone layer. And to oversimplify that, there was Ronald Reagan and Margaret Thatcher. One was a chemist and one had skin cancer. And the depletion of the ozone layer was linked to people's personal health. And they were inspired to act. The other one that I found really interesting is no one was talking about AI 2 years ago. Everyone is talking about AI now. Government's holding hearings about what it's going to mean for people's mental health, for their jobs. So how do we make this personal to people? And I'm sorry, but space sustainability, that's out there. That's Star Trek. Like, space is too disconnected from most people's daily lives. Like, how do we bring it in to something impact them on daily life so that they're prepared to stand up and ask their regulators to regulate this? Because ultimately that's what needs to happen. We need to bring all these externalities in so that they're factored in as a cost of doing business.
We have kind of a combination question. Well, it's a comment posed as a question from Yana Yakashina online. She says, how about changing the message from begging into communication, pushing from negativity towards positivity, and highlighting the role of astronomy and satellites so that it is not so much of an open conflict? Matt, tell us who you are.
Thank you. I work for the SK Observatory in Communications, and I dedicate a bit of my time to supporting communications for the CPS. I wanted to talk about make a comment on the relevance, right? How do we make this relevant to people? And a couple of people earlier have touched on talking about sustainability and about the environment, right? So satellite re-entries, the effect that has on the environment and other such things. And I wanted to give a couple of stats that Andy Lawrence, which I'm sure many of you are familiar with, gave at a recent conference. So he said that by 2030, there'll be 1 Starlink satellite coming down per hour. And I think that's the kind of statistic that is incredibly powerful to use in public messaging. And then he went further and he said he made some based on some models, they made some calculations. Now, I don't know what's behind that, but that by 2030, you'd be looking at a ground death of 0.25 per year from space junk, hitting people, 0.25 per year, and aircraft death of 0.6 per year. Now, if we could do more research into those things and get more such numbers confirmed, that's the kind of thing we need to be telling people about, right? And it's also planetary defense, right? Well, if we can't see, if we can't see an asteroid coming at us, that's a problem. And that's something that people respond to. People respond to emotion, right? They don't respond so well to rational arguments. And this is where I touched on the photography and the work that some of the astrophotographers are doing, which is incredibly important because it's visual. It's a visual medium and it creates emotion. And we need to be tapping more into that. And then I had a second comment on resources. I mean, this is about community engagement, and that goes both ways. And there's a lot of good ideas of, you know, we should do a planetarium show, we should develop materials. Why don't we go to all these great events to give talks? Yes, who's going to do that, right? The CPS is not resourced to do that. The CPS is a volunteer effort, right, with next to no funding. So my plea to everyone in this room is you're the community, you're outreach experts, you're professional communicators, you're astronomers, help us. Become members of the CPS, come with ideas, say, hey, I have $1,000 left, you know, on my budget this year. Can I do something with it to help you? Or I've got a set of resources, or I have got some materials that I did for a school. Please, please help us. We want to put all of this together so that we make resources more available for the community, but we need your help to do that. Thank you.
And for the record, I mean, that's part of what we're doing is trying to create an army of people who are empowered to go out and do that. But again, the industry has placed this burden on us. We did not ask for this, right? And we're getting little support in that regard. So even if we raise up that army of people who are ready to go out there and take the message to the community, other than in their spare time, when are they going to do this? Okay, we have time for one more comment and then we have to move on. So Beth, you get the last word.
Thank you, John. I'm really enjoying this conversation. Thank you so much. Connecting to some things that I've heard and the last comment that we heard is, you know, more research is needed, especially in areas of environmental and otherwise. More resources in broad communication is really needed. And I love the point you made about AI and how much has changed within 2 years or wherever else, sorry. Thank you. Part of the reason for that breakneck change is I think a lot of the progress has happened in industry outside of traditional academic sectors for research, right? And so the structures we're all used to working in don't move at the rate that is needed to move for the kind of research that's needed at the rate that's needed. And so, again, I would love to hear and have conversations about non-traditional NGO type of directions that could potentially be convened to take action now on some of this coordination and research.
And so now we're going to need to close up this session because at the top of the hour, it will be the INT Hub's time. So thank you to Samantha Lawler and everyone here for participating in CE session. And I'll hand it over to, I believe, Patricia Cooper will be leading the next section online.
Thank you, Jessica. I'm Patricia Cooper. I am the president of a consulting company called Constellation Advisory and a former SpaceX executive. And I'm here in the context of being an advisor to the IAU CPS and an advisor to the Industry and Technology Hub. I'm delighted to be here and add to the discussion that we've been having just now and over the past couple days in the General Assembly, and build on the topics that we've just heard about and add a little bit of light. It's been 5 years since SpaceX launched its first tranche of Starlink satellites in May of 2019. I was Vice President of Government Affairs at the time. That triggered not only the concerns that we've been exploring on a technical level here, but also a whole raft of technical inquiries and analysis, research and development, and efforts to understand the intersection of our two communities and also build a dialogue and collaboration between two very, very different communities in our same shared space sector. That collaboration and the practical steps forward is the underlying theme of this coming short session, our industry panel today. And we have an outstanding set of experts to help unpack and shed further light on the other half, so to speak, of this dialogue between satellite and astronomy folks. And also hopefully provide a little additional context for the satellite constellations that are the focus of this entire conference session. So we have a short amount of time to do that, just an hour. So without much ado, I will introduce our speakers briefly and let them get on with what I think will be quite useful conversations. So we have 4 speakers today, and I'm delighted to kick off with Carissa Christensen, who's the CEO of Bryce Tech, which is an analytical and consulting and analysis company that's one of the most trusted in the space sector, and certainly within the satellite sector. They have, I think, a global team now, Carissa, that provides kind of insight and analytics and expertise on the space economy and on the interplay of national security, civil and commercial space programs, technical capabilities, and including satellite markets. So she'll kick us off with kind of the context and drivers for satellite constellations. How have they emerged and why are they growing? We'll then turn to Tim Stevenson, who is the head of assurance at SKAO, but is also the co-chair of the Industry and Technology Hub. I have particularly appreciated his background and insights as someone who's worked both in industry and obviously now in the radio astronomy community. That has allowed him to bridge this conversation with a lot of insight and also just a very common sense approach that has been a delight to work with. Then we will turn to Chris Hofer, who is the international team lead for regulatory affairs at Amazon's Project Kuiper, a satellite constellation project that's just fielded its first 2 test satellites and is driving quickly towards deployment. He is also the other co-chair of the Industry and Technology Hub and a globally recognized leader in radio frequency and spectrum coordination, but has been a leading voice on this issue for several years now. So I'm looking forward for him to give an update on Project Kuiper and their perspective on this. And then finally, we will round it out with Dominique Ponce, who is the head of satellite system engineering at the Eutelsat Group, which recently acquired the OneWeb LEO constellation and that company. But he's going to bring his vantage of 30 some years in the space and satellite industry, and also his perspective as one of the leaders of the Gen 2 next steps for the OneWeb constellation and their technical approach to this kind of question. So we've got a lot of experts to share presentations. I hope someone's going to be screen sharing that now and start off with Carissa's. Is someone screen sharing that, please, in the room, since all of us are virtual? I don't know who in the room is able to do that.
Can you hear me, Patricia? Yes.
Yes, I can. Hi, Federico.
Hi. We are already seeing the first slide of Carissa, and Connie is going to advance the slides at the call from next slide. Okay, thank you.
Okay. Is that also going to be shown on Zoom for those of us who are virtual?
Yes, they're working on that right now. Just a moment. And let us know when you see it so we can
All
start.
right. Well, Carissa, why don't you kick it off? I'm going to send it over to my good friend and guru, Carissa, to get us going. She's got lots to say, and we've got a lot of questions at the end of the session as well. Carissa, over to you.
Thank you, Patricia. It's a pleasure to be here. So Bryce Tech, my company, is an analytics company. We are not an advocacy company. So my job is for government clients and some industry clients to characterize what is going on with a very evidence-based approach. Next slide, please. And so I wanted to provide some context about what is going on in the satellite industry, which is being transformed. So quick framing, when you hear about space, often people think about exploration and science and human spaceflight. That's very much still government driven. The satellite side to the left, the satellite value chain, is already a mature industry. We've relied on satellites for just about all television for decades. As well as other applications like imagery that is used for agriculture and for intelligence purposes. that's the piece of the industry that we're going to talk about today, and that's what's being transformed by a new type of satellite. Next slide. That new type of satellite is really a much smaller satellite. We still build very large satellites like Telstar up in GEO, but we are seeing massive constellations, as you all know, with satellites that are at a much smaller scale. Those are attractive for a number of reasons to both commercial entities and government, national security in particular users. One, you can start small. You can put up a few satellites, demonstrate your concept, and then add more. You can't really put a 1/10 of a GEO satellite in orbit to demonstrate your concept. And also those constellations are viewed as being more resilient. If some satellites fail, the overall constellation doesn't necessarily fail, and also allowing for continual updates of the technology because you're launching replacements. Next slide. One of the enablers of this has been a burst, an unprecedented burst of venture and billionaire super angel investment in space over the last 10 years. It's been about $60 billion in the last 5 years, about almost $50 billion. That's resulted in hundreds of startups focusing on the space ecosystem, about half in launch and about half in satellite-related ventures. Next slide. A consequence of that is we have seen a dramatic increase in the number of satellites deployed. Now, the total upmass and total number of launches has not scaled at the same speed because these satellites are so much smaller. So we've seen not only, as you can see from 2014 to 2023, a dramatic increase in the deployments per year that's resulted in a world that 10 years ago saw about 1,000 active satellites on orbit and now sees about 10,000, but also the vast majority of satellites being deployed today are small sats. Next slide. What do they do? What are they used for? The first bunch, which were smaller constellations in the hundreds, not thousands, were focused on remote sensing and test and development. That's the blue and the purple and the teal on the left. Today, the majority of satellites being deployed are communications satellites, largely focused on delivering broadband services to end users. Next slide. And you can see that those launches have really been dominated by SpaceX. SpaceX's Starlink system has shaped the orbital environment in recent years. Next slide. Next slide. Okay. Another point that's very interesting is while we saw hundreds of startup companies, we've seen activity across many companies. The majority of small sats on orbit are owned, or that have been launched in that period, are owned and operated by a relatively small number of firms, specifically SpaceX and OneWeb, and we would anticipate that operators like Kuiper and some operators in China, for example, will contribute to substantial numbers in the relatively near future. Next slide. The US is very much the dominant nation in terms of the location of satellite operators deploying small sats, with the expectation, with significant activity from China as well, that is expected to grow. Next slide. So this is a bit of a picture of what's likely to happen in the future. And these bubbles, the size of the bubbles represent what I'll call the realistic size of a constellation. So let's take SpaceX, for example. SpaceX has said at various times that it planned to deploy 40,000 satellites. It has FCC approval for 12,000. Of that 12,000, and this chart is already a little out of date, it's actually slightly more than half have been deployed. So the dark green is deployed. And then Chinese company G60 has just done their first deployments. That's a substantial system of on the order of 12,000 satellites. There are other constellations listed here that are iffier in terms of business case. So I think one of the key takeaways is when companies say they are going to do something, that does not mean companies are going to do that. It really is tied to their ability to raise money, their ability to close their business case, their ability to operate on a viable basis. And very importantly, government customers are helping to shape that market. So just to react to some of the conversation that occurred earlier, in addition to the government as a player, as a regulator, which is of course an important conversation here, government agencies that are customers for small sat operators can also help shape the environment. Their funding, their serving as customers can be enabling for some of these systems. Next slide. We're also seeing, and again, remote sensing is on the much smaller number of satellites, hundreds rather than thousands. We're also seeing a number of remote sensing satellites being deployed. And again, government is even a larger user there. Next slide. And I could spend 20 minutes on each of these slides, but I really want to hear what the other experts have to say. So this is a projection that we put together based on our forecast. So our forecast looks at those proposed satellites and evaluates them in terms of their likelihood based on various factors. And if systems like Starlink and Kuiper find their market, if they succeed, if they continue to operate in the next 10 years, the vast majority of satellites deployed will likely be commercial small sats, recognizing that as other factors change, for example, launch capabilities, we may see another shift. But based on the world as it looks now, this is probably what 2030, 10 years from now looks like. And I think that was the last slide. And I very much look forward to the opportunity to answer any questions.
Thank you so much, Carissa. That was, I think, going to prompt a lot of questions and discussion. Tim, we're going to switch over to you. I would just note that many, if not the preponderance of companies that Carissa's slides showed as small sat proposals or constellation proposals have now been signed in to and recruited to participate in the Industry and Technology Hub. So it'll be good for you to give a little bit of a sense of what we're trying to do there and what the path forward is. Tim, over to you.
Thank you very much, Patricia, and thank you very much for making me blush earlier on. I'm Tim Stevenson. I'm the Director of Assurance at the SKA. I'm speaking for my colleagues in the INT Hub, namely Chris and Patricia. You've heard from Patricia, you'll hear from Chris later. And what I'm going to do is to explain what the INT Hub is and how far the INT Hub has got in terms of meeting its objectives, following its objectives. The next slide. So the whole idea is that we enable the thriving of both astronomy and the exploitation of satellites by encouraging collaboration in the identification and the application of mitigation. So that involves raising awareness in the satellite community of the potential to impact astronomy and to encourage the development and adoption of practical mitigations. The hub engages both the technical insights of both the satellite industry, the operators, and indeed the manufacturers and the technologists working in the satellite industry, and astronomers, in order to make it clear to all parties that there are solutions and that they can be adopted. And through making it clear, it makes it more likely that there will be voluntary adoption of those mitigations. Next slide, please. And it does that through these three effective arenas, so to speak. The first one is to enlist industry players. In other words, get them to come to a common table, get them to participate in a meaningful way. And that participation, of course, is collaborating with us, the astronomical community. And that involves informing. Now, I've said this now consistently over several years, and it still remains true for newcomers from industry into the arena where these problems are being addressed. The level of information necessary for operators, constructors, and their technologists, the level of information required is quite high, and they start from a relatively low base. They work on the assumption that astronomy has various protections and that they work and that they are free to operate. I mean, just give you an example that we often hear, we hear it less now, but we often hear from the industry side that radio astronomy is fully protected. And I think you'll hear from other presentations at this meeting that of course isn't true in the modern era. So that's just one example of where industry needs to be informed of the problem. And we are in a situation where now industry comes to the INT Hub and is open to that information, takes away that information and processes it appropriately. And we want then to facilitate an exchange with dialogue between industry stakeholders amongst themselves. This is incredibly important, and we've seen it to be very powerful when we bring together industry players in what I'll introduce in the next slide as the technical advisory group, that they're sharing things amongst themselves, and it makes life very much easier for new players entering into this arena to see that there are practical mitigations, that the progress is being made by their peers and indeed their competitors in addressing the problem. So the status is that we have enlisted 15 companies in the INT Hub. And as Patricia has observed, most of the ones that have been mentioned in Patricia's presentation are indeed already actively participating in the INT Hub. And they are made up of operators who, of course, can specify the systems that they're launching, and also they can operate the systems that they're launching in such a way that makes them much more astronomy friendly. And we also have ongoing outreach towards trade organizations in particular who are, have the leverage over industry as a whole to get this problem understood and to bring individual players into the INT Hub and make regular speaking appearances at industry events. That all helps in enlistment. Informing those who do come to the INT Hub by providing them with the resources, an essential reading list, compilation of best practices, a compendium of known regulatory requirements and conditions, because indeed, quite often the players are not even fully aware of the regulatory environment they operate in, and it's very complex. It's not just the ITU and UN COPUOS. It's national administrations have their own views of these things, which are indeed changing. So keeping operators informed of that is one of the functions of the INT Hub. And a directory of mitigation tools and resources is also useful for those stakeholders, which they can take away and read and ask questions on how these things work out and how they're relevant to them. And exchange amongst industry players, as I've said, turns out to be very, very important. It's based on what we call the Technical Advisory Group. And the TAG has received regular briefings on the concerns of the astronomy community. And there have been sessions on how on-orbit mitigations have worked thus far, the specific concerns of radio astronomy. As I say, the naive position is that radio astronomy is protected, and we have disabused industry of that idea by telling them that modern radio astronomy by no means is protected by what the ITU has allocated across the spectrum. And the third element is the Astronomer Guide program, where industry players can have a nominated astronomer advise them and become part of the communication channel between the community and that particular industry player. And that astronomer guide can be made privy to much more of the intentions of a particular industry player. It's not their job to communicate that to the wider community, but at least they can advise in a much better informed context. And it's clear that industry players value this program very highly. Next slide, please. So this is the summary of observations to date. I think I've covered pretty much of it, and I'm likely to be running out of time if I talk too much. Growing industry awareness and interest in engaging is actually happening, and governments are beginning to become aware, and they are going to ultimately set expectations on industry on how they act, and it gives satellite operators advance notice, because many of them are not anywhere near the deployment phase or even the design phase for their platform, and it gives them a chance to explore solutions. We know from interactions with industry that I have to say that we've never come across an operator who said, we don't give a damn. That's never been said. And I think that's important for the community to know. There is commitment in being good stewards of space. And they need their education and information to sustain and to develop that commitment. It's important to engage them very early in their project life cycle, so that's what we're doing. Best practices need to be well defined and achievable, and in fact, we are well on the way to doing that, doing that work. There's no doubt that more work is needed towards affordable, accessible, and effective mitigation tools and resources, which include the prediction of how bright satellites appear to be, the research into materials such as bidirectional reflectance distribution function tailored material, which are clearly one of the solutions. SpaceX has adopted it, and it's been adopted by other companies as well, to use this special coating, which has been characterized with regard to this particular distribution function. But we need test labs, because there will be competitors to that material, and they need to be characterized if we are to consider them to be a legitimate solution. And on-orbit observations are absolutely critical, and the community is very important in providing well-calibrated, well-characterized observations of these systems, and more research on non-reflective materials, which are clearly going to be part of the solution. Mitigation technology development is still very early in terms of development, and there's more work to be done, and the INT Hub takes its place in encouraging that and communicating any developments to industry as it happens. So I'll stop there. The last slide is contact information for the INT Hub. So if we can move to that.
Next slide, please. Thank you so much, Tim. It's been a little while since, it's been 5 years, which feels like I can sense the feeling that we're behind on this issue, but this is a brand new technology objective, which is to make satellites less visible. On the radio astronomy side, it's a precision in trying to operate both satellites and radio astronomy observations. So we've got a lot of work to do, and I think what I would say is kind of the through line for the INT Hub is to try and look towards really practical steps. If you've got a satellite operator that is of goodwill, as Tim mentions, most are, what do they do next? And do they have the options that allow them to mitigate, to try and take some sorts of steps if they're of the mind to do so? So that's a great tee up for our next conversation with Chris Hofer to talk about Amazon's Project Kuiper. I understand that the interface here is not recognizing Chris's camera, so I think he might just be speaking as a faceless head. I think that's right.
Yes.
Chris, can you?
Yep.
Okay, you're
Good
there.
afternoon,
I'm going to
Patricia.
pass it
Can
over
you
to
hear me?
Chris. I can hear you, but we'll have to just imagine you. Thank you.
Yeah, exactly. So apologies. The Zoom is not seeing my camera, and I've tried a couple different items to get it to work, but it's not working. So we'll be speaking to you invisibly. Apologize for that. I'm with Amazon Project Kuiper. I've been with them for 4.5 years. And of course, we're getting up a new satellite system in the near future. I've been in the spectrum management world for about 25 years now. So a lot of experience dealing with spectrum management in the satellite world throughout my career. Go into the next slide, please. Next slide, please. There we go. You'll see what the mission is of our program: is deliver fast, affordable broadband connectivity to unserved and underserved communities around the world. We're going to be providing some very high performance satellite network broadband services, very fast, affordable broadband around the world. We have a design of 3 shells at the altitudes of 630 kilometers, 610 kilometers, 590 kilometers. And actually these altitudes follow along some of the recommendations from the Dark and Quiet Skies. We're looking at a total of 3,236 satellites in our system, and we'll be looking to serve plus or minus 56 degrees latitude, which is where the majority of the population is around the Earth. And I did hear a little bit of some discussions in the previous session. Just wanted to let you know that the satellite systems are very highly regulated, and we're a US system. So the FCC, we have a very long drawn out licensing process and very specific conditions that have a lot of requirements and rules placed upon us. And also the ITU, related to the satellite filings that go through an examination by the engineers in Geneva, and to make sure that we meet the requirements so that we can share with other primary allocations. So there really is a lot of work and regulation that takes place as we design these systems and implement. Next slide, please. And you'll see on here how we're pointing out that there is a need for high quality broadband around the world, especially rural areas. You'll see some of the numbers there that are around the different parts of the continents around the world. You'll see we believe over 1 billion unserved households around the globe without fixed broadband access, and over 20 million in the US are unserved as well. And so again, we're looking to deliver low cost, high quality broadband to these customers. And just want to let you know that with our speeds and latency, the system will be able to provide backhaul for wireless carriers. So we'll be able to expand 5G into rural areas as well. Next slide, please. And again, I would say typical customers that satellite operators are looking out to reach. We've got the residential, and what's pretty exciting is we have a couple different size antennas. We have one very small antenna that's going to be a square about 7 by 7 inches, and that'll provide up to 100 megabits per second. And then the residential typical antenna that would be placed on a home, for example, size of a small pizza box, about 13 by 13 inches, provide up to 400 megabits per second to the customer. And then we have a larger antenna that's more enterprise to allow up to a gigabit per second. And we see small businesses would be using that type of antenna. Next slide, please. Just wanted to show you sort of the global coverage that we're providing. And the way the system's designed, we'll be launching the set of satellites up to 630 kilometers initially. And so you'll see we'll start to bring in service at the higher latitudes first. So region 1 on this particular graph will show we'll be bringing into service region 1 first, region 2 second, and then third last. So really the customers along the equator will be providing service a little bit later after the customers at the higher latitudes, for example. Next slide, please. All right, space safety sustainability. So given the large number of satellites we're deploying, we built space safety reliability into the program from the very beginning. It's a very key tenet for us. We'll have comprehensive testing on the ground prior to launch, as well as on-orbit testing prior to orbit raising. We've also designed safe space operations into the system. We have 20-kilometer altitude separation between our 3 shells. We're looking at plus or minus 9 kilometers orbital tolerance. And we'll be sharing our ephemeris data and maneuver forecasting to ensure safe operations with others. This will be public data. It's available as supplemental general perturbations, TLEs, on Celestrak. And so that will be provided on a regular basis and not having these several days delay of providing the data. So we're looking forward to providing that, and the radio astronomers will have access, of course. And it's important, as the operations in orbit are, we take the deorbit and demise responsibilities equally seriously. Our active propulsive deorbit will take less than 1 year. And we also selected our orbits from the beginning to ensure that a passive deorbit on natural decay will take no more than 9 years. Next slide, please. Okay, on October 2nd, back in October of last year, we launched 2 test satellites. One satellite, we actually placed dielectric mirrors on the antennas, for example, to test the mitigation of the dielectric mirror. The other satellite, we did not place any mitigation to help collect data. And again, this is basically research and development to figure out exactly what we can do to help minimize the brightness of our satellites. And so part of the system design, being below 1,000 kilometers, will help there. The capabilities of maneuvering to help minimize reflectivity from the solar panels, for example. We have that ability to control the attitude and steering capabilities. And we certainly are very committed. I think you've seen the last few years, this has been very busy, being very active with the radio astronomy community to help feed in the information that's needed and the concerns there to work on minimizing our satellites and the reflectivity the best we can. So a few things from our 2 test satellites that have helped us out. It certainly has helped with our modeling tools. So we use industry standard stray light modeling tools. They're paired with in-house spectral, BRDF and radiometric measurements of all the materials on our spacecraft. The measurements were analyzed during our protoflight mission, which allowed us to correlate our model for estimating reflectivity. So again, our models are being improved through this testing process. And we also made spectral and radiometric measurements of all the materials and coatings used on our spacecraft. And the system level measurements at the spacecraft level, they're not feasible on the ground. And so that's why, of course, we put the dielectric mirror on one satellite, not the other. And we do have actually a meeting a little bit later today with some of the radio astronomers who've been taking some measurements, so we can discuss the data that they have and the data that we have, et cetera, to share that information. And we're always looking to improve the reflectivity of our satellites as well. So with that, I think that concludes my presentation. Thank you.
Thank you so much, Chris. It's great to see the focus and drive that Amazon has placed in their Kuiper project on this topic and on space sustainability generally. And I appreciate not only that insight, but also your support and leadership in the in trying to enlist and inform your counterparts in the satellite sector. So I want to turn to Dominique next, another space industry and satellite industry perspective with a great deal of expertise behind him, and also an operating satellite system with live customers. So I'll hand it over to you, Dominique, and to talk a little bit about the OneWeb project. And apologies if we kind of have taken a little bit of a lag to remember to call it Eutelsat, but we'll do our best. Over to you.
Thank you very much, Patricia. Good afternoon. Next slide, please. Next one. Yeah. So the company is a space pioneer, and especially it was set up in 1977 as an intergovernmental organization. In 2023, you probably heard that Eutelsat started addressing a new frontier in communication by integrating the OneWeb constellation. And the company now operates 35 GEO satellites and 634 LEO satellites. So a bit less than what was shown on the previous slide, but the same ballpark. Clearly, sustainability is core to our DNA, and the company has always set high technical and operational standards for itself, taking additional voluntary steps to further advance space sustainability. I will come back on that a bit later. And the preservation of the space environment is also an integral part of the company's corporate social responsibility policy, because it's clear that we are the users of the space and we are the first interested in what we are doing. Such approach allowed Eutelsat to anticipate and to comply with the most stringent regulations. It is noteworthy that the company is subject to one of the most advanced space sustainability frameworks in Europe, while space operations remain poorly or even not regulated in most countries. Next slide, please. As an example, so while there are still some challenges to solve before active debris removal services become a reality, our LEO constellation satellites already in orbit include by design a grappling feature or magnetic plate, depending on the satellite, to facilitate capture in the event retrieval should become necessary. This is an example of a voluntary step as part of our commitments towards more sustainability in space, even if it was not requested by the time of the design. Although these voluntary steps often incur additional costs for Eutelsat Group, we do believe that they constitute meaningful and necessary steps to maintain a sustainable space environment. Next slide, please, which will be the core of my presentation. So, clearly, dark skies and interest in dark skies is growing, and for the science and society. And Eutelsat Group commenced the inclusion of the topic as a single item on the agenda of the Scientific and Technical Subcommittee of the Committee on the Peaceful Uses of Outer Space, the CUPERS. From a Eutelsat Group perspective, although our LEO satellites are not visible to naked eyes, they may be visible to telescopes. And this is why Eutelsat Group has been taking concrete steps to make sure that the potential impacts of satellites on ground-based astronomy are mitigated. And we are proud to have developed a tool to feed into future design choices of satellite operators, designers, and manufacturers. The software tools aims to estimate and to predict the satellite magnitude by exploiting a mathematical geometrical model of the vehicle, as shown on the bottom left figure of the slide. The thermo-optical properties of the external surfaces, so as the orientations of the satellite body and satellite appendages, for example, the solar rays, are also considered to compute sun and earth fluxes reflected towards an observer on ground. The magnitude is computed along orbital arcs of interest, for example, corresponding to satellites exposed to sunlight, while its external surfaces might reflect flux towards an observer at night on ground. So there are a few specific cases where the satellite can be visible. Eutelsat Group has been engaging with leading international astronomers, such as the Galaxy Observatory, which observatory you can see on the top left figure, to validate these results by optical observation of some of the Gen 1 constellation satellites, and thereby positively influence future designs. You can see on the top right figure some measurements, some observations from this Galaxy satellite. 4 dedicated observation campaigns were run from May to November 2021 in various observation conditions to enrich the correlation landscape. The results, an example is shown on the bottom right figure, reveal that the overall difference between the predicted magnitude, the circles in the figure, and the measured one, which are the squares, is lower than 0.5 for most of the observations, confirming the reliability of the tool. Work is going on to improve the prediction for the few cases where the difference exceeds 0.5, because we think that 0.5 should be the target for this type of tool. Considering these positive results, the tool is now undergoing further development. The objective is to improve the prediction accuracy and to expand it to analyze a variety of satellite models, as well as a variety of material types and external surface shapes. And we have made very positive progress, and it is now our wish to release the software for the benefit of the wider community. And we hope to be able to share it as soon as practicable. And we are looking forward to your engagement and feedback when we will share this tool. Next slide, please. So Space sustainability is a continuous effort to which we are committed. And as such, our next generation of LEO constellation satellites will be designed to show an apparent magnitude greater than 7.8, in line with the IAU CPS recommendations. Just to give you an order of magnitude, 7.8 corresponds to a surface of 26 by 26 centimeters, fully reflecting toward the Earth. So it's just to give you an order of magnitude of the challenge that we have to meet with that. And this is made possible thanks to the results collected from the tool developed in-house, providing a very valuable help to optimize satellite design for brightness reduction. We ran some benchmarks, and the preliminary assessment confirmed that taking care of the satellite apparent magnitude as early as design starts is key, because it drives selection of materials and shapes to strongly limit reflection of sun or earth flux towards an observer on ground. So it's designed for magnitude somehow, the D2M, but worded differently. And then to end my presentation, so thanks to its effort, Eutelsat Group is proud to have recently achieved the platinum rating in space sustainability, the highest accolade of the space sustainability rating, FSR, that you might have heard about. It is a voluntary assessment tool that enables space stakeholders to gauge the sustainability of their project using established metrics. And these additional voluntary steps showcase how Eutelsat Group is really leading by example and willing to go over the extra mile. In this endeavor, we do believe that an open dialogue between operators and the community is key to advance these efforts in the right direction. There were several propositions, and we already support them 100%. So thank you very much. And if you have any feedback or question following the session, please reach out to Chinese or myself on the following slide. Thank you.
Thank you so much, Dominique, and all the speakers. I think have helped to build out maybe a picture of how satellite operators are viewing this topic and how we in the Industry and Technology Hub are trying to raise awareness and maybe at this point, more importantly, identify what kinds of tools, just like what Dominique was describing as a predictive software tool, are available. What do you do next? So I wanted to start out, I know there are going to be some questions online, and I saw one already about optical that we'll turn to, but I wanted to pick up the theme from the conversation just prior to this, which is a lot of confusion about what the business plans were, what the focus was. And I think there was a confluence of maybe a misunderstanding that broadband equates to residential connectivity only. And I wanted to have Carissa pick up on this and say, you know, what are the applications that this broadband as a broad tool you're seeing in sort of a statistical sense? And then I'd like to get Chris and Dominique both to kind of talk about how those various applications within the category of broadband and high-speed internet you're either seeing from your customers already, Dominique, or Chris seeing in your customer target mix. So Carissa, first to you. Unmute. Yep.
I also very much look forward to hearing my colleagues speak about this. So certainly broadband to the end user is something from the perspective of residential users is something that is spoken about a great deal, or small business users, because it falls in that category of the underserved communities. And that's a very obvious, I think it's a very attractive market. And it's got some, you know, there's certainly some policy support for providing services to those communities. That market is insufficient to support the business cases of the proposed satellite systems. Certainly, I'm very interested in hearing a direct from Kuiper about how the system will work with industrial users, given what Amazon does with regard to AWS. The topic that I would hit on is national security users. We've already seen Starlink used in Ukraine as a resource during that conflict. the idea of ubiquitous broadband communication with some potential for securing that communication is very attractive to military users. And certainly there is interest there as well.
So, Dominique, I'm going to ask you to maybe describe a little bit the customer mix you're seeing already with your deployed constellation, and how you're viewing the various applications and customer verticals, as we call them in the business, for OneWeb system now under Eutelsat. I'm trying.
I will try doing that. I cannot disclose everything, but yeah, clearly the business started with communities which were not connected to any fibers. You probably heard about that at the very beginning. So when it was mentioned that fibers is easy to deploy on ground, it's not so easy in all areas. And there was one example also that popped up last year is because of the very big FIs. In fact, it destroys sometimes some terrestrial infrastructure. And without the satellites taking the relay, in fact, it becomes, you create wide, completely no connection in some areas. So there is part of this which are communities supported by government, of course. There are some other cases which is not the core business, but which could also be of interest. I don't know if you heard about that, but over Christmas period, we set up a demonstration from Antarctica for a scientific mission who was able to connect to the rest of the world without having to deploy any terrestrial material. And as mentioned by Carissa, for sure, governments, capability to deploy in some difficult regions, capability to transfer data without going through terrestrial network over, I would say, hostile country, if I can word it like this, is also something that is growing currently. So I cannot say whether it will be exactly that in the future, but for sure there are these areas, and everything about mobility, oil platform in the middle of the sea. There are some cases where it's really beneficial and you have no other way than going through satellite. You can discuss about whether it is GEO, LEO, but you cannot discuss about putting a fiber in the middle of nowhere, if I can make it short.
Yeah, that's very succinct. I think I heard a comment earlier, it's just easier to wire everything up, just lay cable everywhere. And the facts are that the companies that do that just have not seen the business case close to reach everywhere. And sometimes that's because there's too small of a community on the other end. Sometimes it's because that community is geographically complicated to reach. It's mountains or valleys or rivers or islands. And sometimes it's just not where they've gotten yet. It's a very labor intensive process. And that's one of the advantages of satellite. But it's also, I think I would also encourage the astronomers who are just starting to kind of grapple with business case and use cases. I think we will see, my prediction is that we will start seeing use cases that are not direct substitutes for wired or terrestrial services, not just using satellites for cellular or using satellites for residential or small business broadband, but using its kind of always on availability, its geography, its ability to provide mobile over aircraft and ships and large areas. I think we'll start, we're also seeing it in agriculture where there are completely new applications that aren't just direct substitutes for existing services. Chris, is there anything you wanted to add from Kuiper's perspective?
Sure. I had a slide just related to the customers as more general, but totally agree with Carissa. Yeah, the residential business is not enough to support a satellite system by any means, but certainly as we see Earth stations in motion, ESIM is the term we use in the ITU, that has really taken off since about 2009, 2010 timeframe. Really started with the military and the Army. So back before that time, they would have a trailer behind a Humvee with a 2.4 meter antenna that would have to park itself, point at the antenna, and send data back and forth. But while they're on the move, they were unable to communicate. And so really, as we see the military develops a lot of these new technologies, and then eventually they make their way into the commercial world. But certainly mobility is huge. Everybody wants to be connected while on the move. So certainly we see the aircraft connectivity, and the maritime, the ships as well. But also you'll see in the news, even farmers, they're bringing in more accurate data to, John Deere connecting to satellite systems, et cetera. This is just going to keep growing. And this mix of business and customers is what will allow the company to thrive and support these huge expenses up front to get the system up and running. And you really need a multiple list of types of customers. And generally the military customers have higher margin because they need a more robust waveform than, say, a residential customer. To then down to, Wi-Fi community is very popular out there, where I'll use Mexico as an example. You have these villages up in the hills, for example, with a couple hundred people, and it's just too expensive to run fiber or put a tower up there. And so you can drop a satellite antenna into the village and provide Wi-Fi for very low cost. But of course, this is something you can still make a little bit of money off of, that type of business, but you're certainly not going to support the business as a whole. So you have that whole range of what I call higher margin customers and lower margin customers to provide these services around the world. Thank you.
Yeah. Thank you, Chris. I think that's right. Almost all of these companies are going to have a variety of different kinds of applications and customer bases. And I would maybe caution against thinking that all of them are going to have the same mix based on their relationships, their channels of trade, how they're going to approach the market, where they have where they optimize their satellite systems or their terminals. So that I think is going to be different for every company, and they don't necessarily need to publicize it. So there was a question about optical communications and what the future for that was, and it was based from a sense that optical could provide some relief for concerns for RF interference. I don't know, Mike, if that's what you were going to ask. I know it was in the chat. And I know that Starlink is using intersatellite links, spacecraft to spacecraft, and testing out the distances that they can use between the satellites for that. And I think the question was both generally and also for space to ground. I don't know, Dominique or Chris, if either one of you might speak to that. I certainly have some thoughts on the regulation, but if you can give a quick update on where that stands for you all, would be helpful. Dominique, anything from your side?
So for the optical space communication, I would say the current trend is really to have an optical network in space. So connecting the satellites, because this is really the major step. The further step, which is to connect from ground to satellites, to be transparent, we are not yet there because there are a lot of challenges, and in particular, the optical ground stations and the diversity that it might require. Because you know that the higher you go in, especially for the optical communications, you are not immune to bad weather and things like that. So if you want to guarantee an availability of your mission at the same level as today, you will need to deploy more ground station proportionally for the optical links. So I'm quite sure that it will come. I'm not saying it will never come, but it's not the current. The current step is really in space, which already gives a lot of benefits. No doubt that it will come to round, but I see it in a slightly longer term.
Yeah. Chris, anything you wanted to add, or just a quick note on where Kuiper is with its intersatellite optical links?
Yeah, just to add, we definitely have optical links between the satellites to pass the data across the different shells. And our 2 test satellites were up. The testing went very well with the optical data going back and forth. And I think there's a sort of a trend over the years of satellite use, and it really is the technology being developed and the frequencies that can be used on the antennas. And certainly when the geostationary satellites were first launched and taken off, the C-band, in the 3, 4, 6 gigahertz was used first. And then those orbital positions filled up using the C-band. And then the technology evolved to the Ku band, which is around the 10, 14 gigahertz band. And that is pretty much very widely used as well. And then technology took us up to the Ka band, which happens to be the spectrum selected for Kuiper, which is in the 18 to 30 gigahertz range. And we're seeing a trend going up to the V band, which is the 40, 50 gigahertz. And we're looking at what we call the feeder links or the gateways, starting to use those frequency bands. But the customer terminals are still the technology, I would say, just not quite there for the smaller antennas. And so again, I totally agree with Dominique that I don't think the technology is quite there to use optical links from Earth to space or vice versa. But again, I think the military is experimenting with this. And again, I think the military will develop this technology first, and then we may see it in the future in the commercial world. Yep.
And I would just note, I think on the regulatory side, space to ground optical is going to be it's not regulated at this point, and I expect that it would be a complicated regulatory environment just because it'll freak people out. And that's just from several decades of experience of how this will go. I'm very frankly. Mike, I know you've had your hand up very patiently.
Yeah, I just wanted to ask, so I think these presentations have been really great for understanding what's going to happen over the next 3 to 4 years. But I know launch capacity is increasing, for example, particularly with SpaceX with their Starship is able to take a lot higher capacity into space. I'm wondering if, for your insights on the longer future, kind of 10 years, 20 years down the line, what kind of things do you expect to see being launched then? Will there be bigger satellites being launched, things like space labs, things like solar power collectors being back power to Earth? What's on your roadmap for the next 10 years to prevent it being a surprise in the future?
So I'm just going to say, if you could predict that, you will be a very, very rich person. Carissa probably has one of the best industry perspectives in kind of forecasting that, but it's a tough question. Carissa?
It is a tough question. So to take the question of will satellites get larger? Yes, satellites will get larger because satellites always get larger. Even though we've seen the emergence of small satellite constellations, each successive generation of those constellations, you see satellites with more mass. That economics just tend to drive you in that direction. Whether we will see a transition to massive satellites, there's at least one company investing in the concept is very low cost, very massive geosatellites to take advantage of the idea of very large, very low cost launch capacity that, for example, SpaceX has been talking about. I think that's really a question that's going to be answered based on the financial performance of Kuiper and Starlink. Those are the massive constellations, and OneWeb, but OneWeb is a more modestly sized now constellation. So I think that, which, by the way, I think is a brilliant architectural choice. So not criticizing that, but these very large constellations and how they do, and whether they, there's a competitive wedge that can be driven in there with massive constellations, because we have a geo ecosystem that's eroding from a financial standpoint right now. So I think that's an excellent question. I don't think there's a clear answer. With regard to space solar power, I noted in the chat, there are some strong advocates. People love the idea of a sustainable source of power from space. There are multiple government studies. I worked on studies for NASA on space solar power on and off for about 7 years. And I will tell you the economics of that are really still very bad. So huge capital investment, the competition with terrestrial alternatives. There are niche cases, but that's a really tough one to justify. So I would not expect to see that in the next 5 to 10 years.
I would just say, Mike, one of the things that we've noticed, I think Tim would support this too, is that one of the disconnects between the astronomy and satellite communities is the horizon of infrastructure builds. You're working on projects that are 20 years out. That's usually not the horizon for most satellite companies, partly because they're building infrastructure and trying out new applications and testing the market and getting feedback from not only customers, but investors and policymakers. So the horizon just isn't as crisp and stable as it is for astronomers building telescopes. So we've come to the end of the hour. I want to thank our 4 speakers, Tim, Carissa, Dominique, and Chris, for taking time out here. And hopefully this has helped provide some insight to the other side of the conversation and the work that's earnestly underway in both the Industry and Technology Hub and among the satellite stakeholders. So thank you all for having us, and
Patricia?
I wish you a good conference. Yes.
Patricia, yes, thank you so much. We really, really, really learned a lot from your expertise, all four of you, all five of you, actually, because Chris, we can't see you, but we know you're there. But I was wondering if we would have the opportunity to have people in the audience just ask you one or two questions, because they haven't really had a chance to do that. So does anyone in the audience?
If you all can hang on for a little bit, I'm open to it. Yep, thumbs up for everyone. Chris, I assume you're a yes. Tim, you okay? Okay. Yeah, why don't we stay on for another 15 minutes, say?
Well, at least 5.
If we
let's see what people can do.
Yeah.
Okay, so okay. We have a question from, sorry.
Hi, this is Yazwant from the American Astronomical Society. So I think it's wonderful the things y'all have been doing to set new norms and standards for the industry, which has been really, really wonderful to see, especially given, let's be honest, the glacial pace of most regulatory bodies. So that's been really, really nice to see. My question is, how do we encourage more folks in the industry to embrace these norms and standards, especially given the large growth in the smaller space companies, say the startups, who may not have the resources to invest as much in sustainability efforts?
Yeah, I'm going to take that one, and then I'll pass it over to Tim as well. I think the most important thing, the first step is awareness, and I think we're working on that. There's quite a few methods and I think avenues to make sure that satellite operators are aware. But I would maybe redirect you from this phrase standards and norms, because we're so early in the technology phase. There are really only 3, for example, for optical mitigation, only 3 trials that have been done. There's painting it black, there's using a sunshade, and there's using these various coatings. And I haven't heard that any of those are a slam dunk from the astronomer's satisfaction perspective. So we have to actually invest in more options, more research and development, more experimentation, and also the feedback loop in testing and on-orbit observation and the predictive software that Dominique mentioned to identify whether those trials and options are successful. And only then can you say, this is what everyone should be doing. Tim, I don't know if you want to have anything you want to add to that.
Yeah, I was going to say, and we have to do it together. So this is where we think we've established a sort of competition-free zone. Industry seems to be very willing to pull itself up by its own bootstraps and share critical information, which means that a newcomer can consider mitigations much more cheaply. They don't have to cast about, do much of their own research. They can specify a system that uses, for instance, if they're doing a prototype, they can specify a system that uses much, if not all, of the current mitigations that are publicly available, get it modeled by the good offices of Eutelsat, who now are offering a model that allows you to predict how your system will look, and then deploy a system, a prototype, and have it observed by the community. If they had to do all of that on their own, it would cost them a vast amount, and they would be very inhibited, and it would put off their investors. We have this readily available to them to at least make inroads into the problem at the very lowest cost. And I think we've been pretty darn successful in achieving that.
So,
Connie, is there another question from the audience?
Yeah, this is Jessica Heim. I had a question that relates to some discussion that we had earlier in our CE Hub discussion. And so, like, one idea that has been raised by some astronomers is, okay, like, you know, the concern about what is the orbital carrying capacity, like, for, like, safe satellite operations, all these different things are looking at being launched, what is the safe carrying capacity? And so, like, the idea has been thrown about, like, okay, well, is there a way that, like, satellites can be designed to last longer so you don't have to have re-entry all the time? And is there a way that companies can share infrastructure? And then I know, like, there's a lot of intellectual property issues associated with that, but then the analogy was given of, oh, well, like, you know, broad ground-based cell carriers, they will share towers, things like that. So, like, what is your thought on, like, is there any sort of future in which there can be, like, reduction in total number of satellites due to more sharing among industry, or, like, satellites being able to last longer so we don't have to burn them up in the atmosphere all the time? Thanks.
Yeah, I'll take a quick crack at the start of it, and then ask Dominique maybe on the carrying capacity, and Carissa on the sort of shared infrastructure side. So I think there's been a lot of interest in trying to put a finite number on this is how many is safe. And I don't think we've seen a good approach to understanding that, just because the variables are changing so much, both the capabilities of the spacecraft in terms of being able to collision avoid or to re-enter, looking at assistance and active debris removal or active deorbit, and also the information about what's online is improving. So I don't know that we have a good handle on how to calculate that, because the metrics are all are changing so rapidly. Even for our satellite context, this industry development has been extremely fast. It's partly because Starlink has been so fast. Dominique, anything you want to say about carrying capacity and what's a safe number on orbit, and how that plays out from your perspective?
Yeah, if I may, regarding the lifetime, it was mentioned, we are also interested in increasing the lifetime of the satellites. Currently, the limitation comes from the space environment and the radiations. So really, on Gen 1, we targeted 5 years. We think that they will go to 7 years because there are some margins, and the next generation will go even a step further. So we are all interested in going in this direction, but technology has a limit currently. There is also another component which starts to grow, which is we are discussing a lot with people having hosted payloads. So instead of having everybody having its own satellite, in fact, we really started to collaborate with several suppliers and several entities who are ready to have a subset of our satellites flying their payload. And I think this will be also, personally, I think it is a trend that will come in the near future. And it is true for LEOs, but also for GEOs. It's really a change of mind where instead of having everybody being kind to have his or her own satellites, sharing just hosting the capability on somebody else's satellite.
I agree. I think, well, I also want to say, I think because as long as the applications and the mix of services and the technical requirements of that are in flux, I think that drives away from, kind of building larger and larger satellites with longer lives, because you don't know what service you're going to provide in 5 to 7 years. Cell phones cycle every 18 months. I don't know what we did with the broadband 5 years ago. And so a 7-year-old satellite might be wildly out of date. Carissa, can you talk to how the finances drive towards larger satellites, which you described a little bit earlier, and how it might drive also to shared infrastructure?
Well, so it's interesting, the larger your satellite is, the more capable it is, kind of very, very shorthand idea. And launch has historically been a significant cost. And so as Dominique talked about, a larger satellite typically has a longer life. On the shared infrastructure topic, I think that the hosted payloads point is very interesting and a very, very well taken. There have been many concepts for essentially permanent satellite platforms where you've got either software defined or hardware that's sensors or comm capability, or the ability to swap out kind of with a modular model. The reason that we're seeing the investment thesis around these large LEO constellations right now hits on a number of factors that value those relatively small satellites. One, again, is the idea that a big constellation with lots of satellites in it is very robust in terms of its performance at the constellation level. So you can afford to have individual satellites fail, but you will be able to deliver high quality service even if that's the case. It's also, again, the investment thesis around those large systems has been that you can, and Patricia, you touched on this, infuse new technology so that as you're not launching a geo satellite and having it on orbit for 15 to 20 years, you can operate on a refresh cycle that's more aligned with the refresh cycle that we see with terrestrial technology. The other thing, just sort of very simplistically thinking about communication satellite systems, is it's a resource that can be used up. It's not, I take an image and a million people can use that same image. And of course, there are capacity limitations and issues with remote sensing systems. The telecom systems, they can get congested. They can have their performance eroded because they're over congested. So at a very simple level, the amount of infrastructure is kind of a supply and demand question.
Yeah. Chris, I think you had something you wanted to add from your dark face.
Just to touch. I mean, certainly agree with all the previous speakers answering the questions, but certainly, the satellite operators have environmental engineers, and they're designing the materials and picking the best materials possible to be on these satellites, and they are interested in having as much life out of these satellites as possible. So these typical LEOs are in the seven plus range lifetime, and certainly there would be some interest for some more time to have satellites up there. I do agree there's kind of a range in there where they may become obsolete because things are just changing so fast right now, and everyone's looking to improve the design and improve the capabilities, but also need to keep in mind fuel, for example. So these satellites are maintaining their orbits, and at times there's only so much fuel that can be used to do that, and so they may need to be safely brought down for the space sustainability aspect. Thank you.
Thank you all. I'm going to close out now. I know you've got other sessions to go to. I appreciate your attention. I appreciate good questions. And for all of our speakers, I appreciate you sharing your crazy deep expertise with us and your goodwill. Have a good conference, everyone.
Yeah,
take care.
Thank you. Thank you very much, Patricia. I was going to exactly close at that. Thank you very much, and thanks a lot for staying a little bit longer. Some of the people flew here, but I think many people stayed online. I saw a lot of comments there. So yeah, thank you very much and see you soon. Bye-bye.